Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential.
Hello everyone, welcome to WeAreDevelopers Live. I'm Sead and I'm your host for the Machine Learning Day. We have 4 interesting talks in front of us. We're going to talk about ML models, NLP, data, TensorFlow and so much more. Before we start, a couple of things. First, check out the WeAreDevelopers World Congress. If you are a developer, you don't want to miss this event. It takes place online end of June. Thousands of like-minded peers from all around the world are going to join this event. There will be great speakers with great content. Check it out on wearedevelopers.com/world-congress. Second, I want to say a big thank you to UiPath, who are our partner of the day and make the Machine Learning Day possible. For the ones who don't know, UiPath is one of the industry-leading platforms for robotic process automation. So thank you, my friends, for making this day possible. And third, as always, feel free to join the discussion and take the chance to ask your questions to the speakers. Use the Q&A tool on wearedevelopers.com/live just besides the stream. The speakers will be happy to answer your questions right after their sessions. And last but not least, please comply with our code of conduct, be nice to each other, treat everyone with respect. Here's a short video about that. In the meantime, I'm going to get our first speaker on stage. So I am back here with Mario. Mario is the head of data at Uniqua Insurance Group. Mario, hello, welcome. How are you?
Hello, Sead. Thanks. I am pretty well. Hope you're well too.
Yes. So Mario, tell us, what are we going to learn from you today?
Yeah, I'm talking about a new design concept around data. So I will not talk about the typical machine learning things which you would expect. So I'm talking about the data mesh, which is kind of like a possible solution for large companies to get faster to machine learning. So I'm talking about the fundamentals and the problems companies, large enterprises such as UNIQA and a lot of others are struggling with when it comes to data, because we are all talking about the fancy machine learning, data science stuff, but the problems lie somewhere else.
Okay, that sounds interesting. Looking forward to that. So Mario, I would say that the stage is yours.
Yeah, so hi and welcome to my talk about the data mesh. As already announced by Sead before, my name is Meir-Huber and I'm the head of data of Uniqua Insurance Group. First of all, I want to have everyone welcome to UNIQA. I think if you're in or around Vienna, you pretty much know our headquarters. It's the fancy tower, which is covered in different colors throughout the night. So as you can see from the background, I'm currently sitting within this tower, slowly getting back to the office. Before we start, to give you a setting of what UNIQA is all about and to give you an overview what we are struggling with in the data field. We are making some 5.5 billion revenue. We are one of the premium insurers in Central and Eastern Europe. We have 21 million contracts before we acquired AXA last year. We have 21,000 employees and we are in 18 markets. So on the landscape here, you can see our core markets. Our headquarters is Austria, plus we have a real large number of other markets which we're covering. The other question is, who is now talking to you? As already pre-announced, I'm head of data at Uniqua Insurance Group, reporting to the board of the group. Not a different format, not one of the countries. Before that, I was at A1 and former Microsoftie as well, and book author on different books on cloud computing in 2009. This was already pretty long time ago, I would say, 2019. I published a book with a couple of other co-authors named Data Science in the Enterprise. And in a pre-pandemic world, I was a speaker at a lot of global events. Now the global events take place on my desk, more or less. But for instance, I was at the events speaking about data handling and the London Tech Week and the Chitex in Dubai and so on and so forth. If you want to reach out to me, you can always reach out to me via my LinkedIn profile, which is just my name, or my Twitter handle, or read my blog on cloudwayne.net, where I'm publishing these and other topics. So what am I going to talk about today? The one thing, just as hopefully I'm not disappointing you, I will not talk about fancy machine learning topics, because when we want to go to machine learning, we first need to solve other topics around data handling itself. So I want to give you an overview about the data mesh, which is a design principle for handling data application. It's and data science, because it's a fundamental thing to do before. So first of all, I want to ask you, and unfortunately I can't see your hands going up. My question is, are you rather on the left side, which is a large corporation, or on the right side if you're working in a startup or a small medium enterprise? Because that's a huge difference if you're in either the one or the other. So large corporations struggle with other problems in contrast to startups. But there's one clear thing, that big corporations are always struggling with data. There are various aspects why large corporations, as like we are struggling with data. There are different problems associated with it. And I will walk you through the problems, and then I will tell you why data mesh will solve, not all of them, but quite a big number of those problems. So first, it's about the distributed data ownership. Meaning that large corporations like UNIQA, we have 21,000 people, we have 18 markets we are active in, we have a large number of different functions within the company. And it's simply impossible to control all the data. It's simply impossible to have an overview of what's happening with data everywhere. Plus, individual departments buy data, individual departments acquire data from different aspects. And often we come, in this case, to a very distributed data ownership, which is resulting in silos eventually. Then a really, really big issue. If you're in a startup, you probably heard about this famous term legacy, but you really don't have to deal with it, because there is nothing on about the legacy topics. But if you're working in a large enterprise, legacy is giving you sleepless nights. It's giving you a lot of pain, because the systems have been around for not just years, decades. We have systems which have been in place for maybe 30 years. You remember the time, what system languages you were using there? There's no way to work with fancy tools such as Python. You have to code COBOL. And this is actually pretty advanced if you're already on COBOL. So getting the data out of those legacy systems, that's really, really painful. So legacy is killing a lot of of innovation in those large companies. And removing the legacy systems, something which was running pretty well for the last 30 years, replacing it. This is not just a technical challenge, it's an organizational challenge, and this is not easy to be addressed. Siloed data. So there's this statement, be twice as performant than we are. I don't know if it's really like twice or 3 or 4 times. I don't have any idea. Sorry, too many meetings today is getting my voice away. And the siloed data is definitely a huge problem in large companies. And there are so many silos, and you have duplicates of data. Incredible. And it's so tough to get all this data in an overview and get all this data together. So as I promised you before, today I will not talk about machine learning. I will talk about how to make machine learning work in large companies and the complex and long-lasting processes and how to get there. And it's not something which you can solve within a week or month. It's rather a process that takes years. This is the hard truth and the inconvenient truth in large corporations. So to give you a bit of a history, what was the history of data in large corporations? What did we do, and where are we coming from, and why are we struggling with it so much as well? So we had a couple of evolution. So the first evolution in handling data was the data warehouse. It was the first promise to solve all our problems. The goal of the data warehouse was to have all the data together in one single place. We have one format for analytical purposes. It's all SQL based, and everybody can work with it. So this was the nice promise about the data warehouse, but there was something significantly wrong. What was wrong? It turned out to be really expensive. So you all know the Teradata's, the Oracles in the world out there, and how much big companies paid for it. So scaling out those databases was just a matter of a question of cost. The more you plug in, the more you get. But it was never really paid off in this large amounts of what it was designed for. And another problem was that it was not suitable for other data formats. Of course, the data warehouse providers would argue with me now because it does support other data formats, but yeah, it was built in because there was some pressure from the market. But the data warehouse, as we know it right now, was not suitable for handling data workloads. I'm talking more about the classical data warehouse because there are more advanced solutions now out in the market, but I'm not going into details with that. So what was the first answer to data warehousing? We had like in 2006, 7, 8, we had this evolution starting, the second evolution. It was called the data lake. In the last couple of years, everybody was arguing, we have to build one data lake, we put all the data together and have all the data centralized and harmonized for our data workload so that data scientists can work with the data. The goal with the data lake was to add much more flexibility, to add a much higher scale, and to, of course, lower the cost eventually of running analytical workloads and of doing machine learning and data science on it. So the data lake was a pretty nice promise, and it turned out in most cases that it's pretty efficient. So it gave us a lot of benefits of this centralized platform. What was it mainly built with? I'm pretty sure everybody have heard of the term Hadoop. This was the main tooling or the platform where big data platforms and the data lake was built and made up of. So what happened? Why did it not turn out to be the solution for all? Why is it now getting replaced by other ideas? So first, it came with terrible governance. It was impossible to harmonize and centralize all data from a cost perspective. So the governance issues, which were already solved on the data warehouse they now were reset to zero. We basically had to reinvent data governance for the data lake. I remember the first initiatives bringing data governance toolings to the data lake, bringing data governance documents, writing guidelines for the data lake. And it was so much like, okay, all of that has been here in the data warehouse. We have to reinvent it because the data lake is a different technology. Plus, what really most companies were struggling with when we came to the data lake was this terrible thing about making this Hadoop platform work. You know, so many companies struggling for months or even for years to bring this platform to work as it is supposed to work, because it's complex and not much knowledge was out there. But one thing with all those approaches that we had is the single weakest point of all the two evolutions we saw. The data is and will always be decentral and will always be driven by a business domain. This is the first two evolutions. They were an approach to try to solve something from a technical point of view, which is where there is no technical solution, because there can only be a cultural and organizational solution to get data handling right. The technology just follows suit, and we always try to solve everything with technology. That's how we as software architects or engineers are. We see a problem, we see a technical solution, but in most of the cases, the technical solution is not the solution. It's just a tooling that can do something for us, but the solution is always an organizational or cultural solution. So now we have a new evolution called the data mesh. And with the data mesh, we're moving away from this concept or from this idea of solving everything with a technical thing, with a technical solution. So the data mesh is not a software which you can install. It's not a platform which you can run somewhere. The data mesh is not something where you can set up your containers, Dockerize them, and start a container called data mesh. There is no such thing. The data mesh is a concept. It's an architectural blueprint. And what's more, it's an organizational and cultural guideline on what problems need to be solved. The data mesh eventually can and probably will in a lot of cases reuse data lakes, will reuse data warehouses, but will also reuse other things among them. So it's basically centralized around something else. It's centralized around the business, and it's not so much centralized around the technology that's being used. The technology is very unimportant for the data mesh. So what's really important about the data mesh as well is accepting the distributed and decentralized manner of data and actually embracing it. And that's, I would say, is the strongest point about the data mesh. So when we look into what will the data mesh solve, there are a couple of items that we are doing wrong with solving, working with data at present. So we have three key points. The first one is not focusing on the business. Second one is the focus strictly on the ETL, extract, transform, load process. The third one is building a monolith versus like data lake or data warehouse, which I was mentioning before. So I want to walk you through the first pain point. The first pain point, and this is the strongest one, is not focusing on the business. So every business department has their business problems. And we as engineers strive towards building fancy solutions for that, which often the business doesn't need. The business, like a sales department, a marketing department, is never getting any reward for having a cool data lake in the background. That's not where they are charged, and that's not where they are measured against. They are measured against numbers. They want to solve problems. And data engineers, data architects often want to solve complex technical solutions. So basically, this problem between business and IT is one of the key pain points there. plus the fact that the data engineers and scientists, they are often hyper-specialized within IT organizations, within a central IT department, and don't see the broader business need for it. So the data mesh concept basically focuses really strictly on the business. I will go into that later on. But what's the another pain point? Because the data knowledge, the knowledge about the data is often in the business. And by knowledge, I do not mean the platform itself. I mean the domain-specific topics. So for instance, if you are working in a marketing department, you know best what the marketing data is all about. If you're working in a sales department, you know what the sales data is about. What's the representation of the data? What's the purpose of the data? What's the background? Why it's being produced the same way as it is being produced. If you're in a telco and you're working in a networking department, you know exactly everything about the data being produced in the networking department and what it means from a network point of view. If you are in an insurance, you know everything about the claims. If you're in a claim department, you know about the data there. If you're in a factory, you know the business, the floor, or the shop floor managers or people working there know what the machine data, what the data the machine is producing. But IT departments don't have any clue about the data. They don't have any clue what the data means. They do have a pretty good view on the systems and the platforms, but data is domain-centric. It's very focused on the domain, on the business domain. And it's generated in the business domains, it's used in the business domains. And if IT is handling all those workloads, it takes too long to understand what the data is all about. So I have this idea in mind that probably because IT knows that we as IT departments don't understand the data well, we try not to get to a point where we have to understand the data. So we just build complex solutions because that's what we're good in. But that's not what's bringing the company forward. If we want to be successful in data, we need to focus on the business domain and we need to get much closer to the business. And this is what we've been struggling in the past, and I've been struggling with that a lot as well. The second pain point is, again, we focus too much on the ingest process, on the pipelines, on the extract, transform, load pipelines. And but we should focus on something else. We should focus on the domain-specific aspects of data. So we are just trying to cleanse the data, aggregate it, enrich it, and often we don't know what all of it is about. And last but not least, I was already mentioning this a couple of times today, is this building of a monolith. I saw a lot of big data projects. I saw a lot of data lake implementations. It's taking so freaking long. Implementing a Hadoop platform, I mean, if you can do it in half a year, you're pretty fast. Most companies are dealing with that for 1 year, 1.5 years, even longer. And business doesn't have time to wait for an implementation, saying like, okay, for instance, we as insurer, we need to do IFRS. We need to do this because it's mandatory from a regulatory perspective. If we would now say, okay, we'll do it in 3 years from now, because first we have to build this data lake, being capable of handling it, business, they will kill me. And also the regulatory, so we will have to pay a lot of fees to them. So basically the saying here is stop building all those monoliths, stop building all this big chunky data warehouses and data lakes, which you can have, which will cause so many problems. Stop building them because it's already built somewhere else and you can just reuse it. If you look at the public cloud, all of those tools are here out of the box. You can start them. You can ingest the data there and you can start working and playing with the data and give a business purpose to it. So do not wait for this buildup of the big data platforms. It doesn't bring any benefit. So now is the question, what is the data mesh solving? Because it's tackling all of these problems, or most of them. And what are the key building blocks and how will it solve or is trying to solve those kind of problems? So basically, data is being brought into different domains. So we have this distributed domain-driven architecture. We have self-service platform design, And then we have the last, which is very important, is this product thinking. I will talk about all of the three of them now, how it's being solved. The first one is building a domain, the distributed domain-driven architecture. Oops, this was too much. So basically, the data mesh is really focused on a microservices architecture, meaning that we built a really easy-to-use solution tailored to the needs of what we're going to solve. We have a business problem. What's the fastest and best way to solve this problem? The architecture follows the needs of the business project, of the business problems. We're not creating a technical problem for a business problem. We are solving that by using the right architecture, using the right tools for the right for specific use case, and try to keep the architecture as simple as possible. We build the data services for the domain. We do not build a large enterprise data model, which nobody understands, and where you need hundreds of analysts to build a comprehensive 360-degree view of all the company data. We build the data to specific domains. If you're in an insurance company, we build a data model for claims, fraud, and the like. But we have to make sure that the data eventually stays connectable by having unified identifiers, stuff like that. So we architect the data from a systems perspective in the easiest way, in the less complex solution. And we build the models tailored to the domain needs, closely with the business, driven by the business, and probably just within the business. So as you can see here, the role of the IT will get lower and lower. What does it mean from a business perspective? I would say in the future, at the moment we have banks having an IT department. In the future, which is not far away, we already have this right now. When we look at N26, for instance, N26 is a software company offering banking products. You see what's different there? There are banks having an IT department, have a software engineering department, but software engineering will never be the first of their approaches or their things. N26 is a software company offering products around banking. And at the moment we have insurance companies with IT departments. In the future, we will have software companies offering insurance products. That's digitalization, and data plays the key in that. So everything is domain driven by the business. And the data services which we are building come with the concept of the architectural quantum, which is one of the statements of the microservice architecture. And there is a clear and very strong ownership of the data within the business. The use case teams work either with the business or even within the business. So when you are familiar with how Spotify is built up, they are organized in tribes, chapters, squads, and the like. And this is how use case teams with this distributed domain-driven architecture can work and will work in the future. And we're talking about the architectural quantum. Again, the key aspects of that are using the simplest and easiest architecture possible for data workloads. So don't overcomplicate the architecture. Don't build something for years. Just use what's existing. The architecture follows the domain demand, not a complex monolithic system. So for instance, if there's a business problem, you should not force the business to use an architecture which is too complex to deliver. The business problem should not create a technical problem. And data is domain-driven and source-oriented. So where the data is being produced, that's the source, and that's often always in the business. Then the second out of the three is the self-serve platform design. So this is a pretty exciting thing because when we are talking about machine learning and about data science, we're always talking about applying algorithms to data. And if you talk to data scientists out there, if you ask them what are they most busy with, a lot of people will not answer, I'm not sure which algorithm to use. I don't know if if deep learning, if a convolutional network is better for my use case, or if I should go back to random forest or whatever. This is not the problem they are focusing on. They are not focusing on the statistical problems. Often they are trying and struggling to get access to the data. And getting access to the data is often a key issue there. So what the data mesh is built on is the self-serve platform design, basically stating that companies should not focus on the infrastructure, because the infrastructural problems, they are already solved problems for years, and they are solved by platform as a service solutions. So if you look at the companies being successful in machine learning, all of them use public cloud platforms like AWS, Azure, or Google Cloud, because they don't have any stake in building up this complex stack for handling data. And often they don't have the know-how and the people for doing so. At the self-service platform design, what you get is the focus on solving data problems, not IT infrastructure problems. With the data mesh, a clear recommendation is to use services such as S3 for storing data, or other cloud storages rather than HDFS, or even other platforms. There are so many other platforms available, other databases available in the public cloud. You are free to use whatever you want. And use the use of pre-built cloud platforms in a self-service manner. So for instance, if you're using Spark, don't create your own Spark cluster, but use services which are already out of the box available, such as Azure Synapse. AWS has services, Google has BigQuery. So there's so much available where you can solve problems within a really limited amount of time. It doesn't require you to reinvent the wheel over and over again, because it's being built there. And I would basically argue that no IT department of large corporations is better than what Microsoft, Google, and Amazon can do, because they have so much more know-how on this, on the automation aspects. So focus on serving your business needs. You don't want to reinvent the platform, or you don't want to rebuild the cloud. What's important here, just because the self-serve platform bring a lot of tooling with it, it's also important to automate your efforts as much as possible, to use CI/CD pipelining and stuff like that. And last but not least, which is really crucial to the data mesh architecture, is this concept of data as a product. So what does data as a product mean? Basically, coming again with this statement, we have data is the fuel of digitalization. So if you want to be a digital company, you need to have your data in shape. This means that you need to refine what you would sell to your customer. And you should treat data the same. So whoever is responsible for data in the domain, and the data domain, which is in the business, is responsible for the data quality. If you offer it as a product to others, you need to ensure that it's available at a really high quality and at high availability and alike. And what data as a product also states, data should be served to others. So for instance, if you're a business department, the data should not just be within your department. You should serve it to all other departments, if possible by regulatory, of course, to other departments, to other people. If a data scientist needs to have insights on data, it should be offered in a self-service manner. And quality needs to be fine. So what's necessary to offer data as a product? There are quite a lot of things necessary to achieve that. First of all, I'll create data governance can solve that. And what does it stand for? First of all, yes, of course, it only works with data governance. But what are the key building blocks of data as a product? The key building blocks for that are that the data products are offered by domains, business users, as polyglot data products. And there are a couple of items relevant to that. So first, data needs to be discoverable via data catalogs. So for instance, if you're a data scientist within your company, you should have a central data catalog where you can look up all the data which is available within your company. All the different data domains that produce data, and the data catalog needs to fulfill a couple of items, such as when was it produced, how can I access the data, what do you expect to get within the data, and what's inside the data, to have a sample data catalog, a sample data available. So then you can already start thinking about your algorithms, and you can start about what kind of algorithm are you going to build if you have a data catalog that gives you an overview of what data is available. How is the data catalog currently solved in most companies? There is no data catalog. There's someone that knows someone else, and this is the data catalog. So it's built on networks, and if you're a data scientist, you know probably someone that knows someone that could know someone that could know the data. And this process takes long. If you have a central data catalog, you exactly know who is responsible for the data, whom can you approach, and what's actually inside the data. So you can start building or conceptualizing your algorithm by knowing, okay, the data is available. That's how the data set will look like. So let's ask for access in a self-service way, and you'll get access to the data normally then, or hopefully rather fast, and it doesn't take you a month to ask from one side to the other. Next, it must be addressable. Data must be offered by a department via a clear API. The API must be described, and a clear description must be available, and it should not have a lot of changes within it. So if you offer an API, there should be some stability within this API. And once a data scientist has access to the data, implementing the API, querying the API should be straightforward. There are a lot of different APIs available. It doesn't matter much which one you're using, just have an API which describes the data. Then data must be trustworthy. Of course, if you want to use data from a different department, you must be sure to trust the data. There must be a service level agreement available. How are you going to serve the data, and to be sure that the data is correct and up to date? You don't want to have customer data and then you see last updated 2 years ago. You can be pretty sure that the customer data is not up to date. It's not trustworthy in this case. Then it's very important to have a self-description of the data, which is often integrated into the data catalog, but you need to have clear metadata. Metadata we define as data about the data available. So basically, there must be a description of what columns can you expect within the data, what values can you see within the data, what are the names of the columns, the meaning of the columns. So there's so many data sets out there which have a really, really strange description. So the columns are named like something which you do not understand. Yeah, probably a machine doesn't understand it. An algorithm probably doesn't understand it because it's coded somewhere. But if there is no metadata, what does it mean and what values can you expect? For instance, is this a field where you can have a 1 to 10 ranking, whatever? There must be always a clear data about the metadata. And then there must be a high interoperability by following standards. So if you're working in a large organization, don't reinvent the wheel. There are so many data standards out there for insurance, for banking, for telcos, for retail. There are organizations working on that. It's easier to buy those standards, to apply to those standards, than reinventing the wheel, because a customer is a customer everywhere. And there's so many things which are similar. You can still tailor it to your specific needs, but make sure that it's interoperable. If you do updates on your data model in the business domain, describe the updates and inform the stakeholders by the API. And last but not least, data must always be secure. So you must make sure that all the standards are being followed in terms of encryption, in terms of anonymization, and in terms of access rights. You must track who is accessing the data for what use case. And security is very important. So all of that defines the data as a product in terms of the data mesh. And there are quite some items to fulfill, and but I would say they are manageable. So the question is, last but not least, will it solve all our problems? For sure not. It's definitely not solving all our problems, but it will make our lives ways easier in working with data in large companies, or probably also in the smaller ones or in the startup field. Okay, that's it from my session. It's pretty much on time. And now we have possibility to discuss about the data mesh and what you think about this idea and how you like this idea of data mesh. Thank you.
Okay. Thank you, Mario. Thank you very much for this presentation. Very insightful. We have a lot of questions, and I would say we just start with the first one. So maybe we can get Slido.
Can I see the questions somewhere?
Yes.
Yeah.
So let's pick it one by one. So first question by Mr. Anonymous is, would this approach mean that you need more data specialists across the organization to handle the specific areas? Means you still need more expert resources?
Yes and no. In whatever company I was working with, there are always experts in specific departments, knowing about the data, knowing about the handling data. And you would be surprised how long it takes to figure those people out. So I had a couple of, when I was working in my previous company, there was suddenly someone popping up which was really good in this specific data domain. And there is someone in UNIQA, there are a lot of people which are very familiar with specific data set. So those people they do exist, you just need to make them visible. And you need to make sure that there's a community around them so that they start exchanging. But yes, I would say digitalization is becoming a key asset, or it already is a key asset. It's not becoming one. Digitalization is what we're all talking about for years now. But yes, everybody needs to have much more skills in this area. I don't think that you need to hire a huge number of data scientists, probably a larger number of data engineers, because that's what most companies are missing out with. But you can and upskill a lot of people within an organization. So I would say it's a mixture. You hire new people to bring in new experiences, plus you upskill existing people, because there's so many people that wants to move into the domain. Give them the possibility. And I would not say it's just their job to get familiar with data science and data engineering. The company should offer in the long run such kind of educational programs, because hiring a large number of data engineers, we all know it's utopic, because you can't do it because all the people wants to hire data engineers and data scientists.
Yeah, so
it's
a bit tough on the market,
they're not jobless out there.
Yeah,
they're not desperately working for a job.
I think this was the point of the question. Like, you would need to have more experts on this topic across the whole organization and kind of distribute the knowledge a bit. But I think the answer with also mixing the solution with also upskilling people is maybe not at that wrong. So it's could, but definitely it's becoming more and more important. I would say let's go to the next question, but maybe not the next in the list. That is a bit connected. Who should decide what data is relevant for the business? Especially if you have decentralized data, so maybe this is a This is an interesting question.
No, who should decide what data is relevant for the business? That's clearly business. Business decides what data they need. They often start collecting it on their own. So business is in the lead, business is the owner, business decides what data is relevant for them. I cannot tell marketing how to do their job. That's but they are much better than I am. They need to tell me what data they need, and then we try to figure it out, where can we get it from. So yeah.
Okay. Then the next question, I'll take another one from an anonymous viewer, because it's also quite interesting. How do you get buy-in for data as a product initiatives from leadership?
I'm reporting to the board. It's different. A lot of board members do understand it as being important. It's just a constant way of evangelizing and convincing the people, working with the people, with the leadership, the C-1. Those are basically pre-preparing the decisions for C-level. But you need to work with those. You need to create networks within a company. You need to convince people, and you need to work with the people on giving them the benefits. So if everybody has a benefit from having a better data, eventually they will buy into that. So we are here at UNIQA, we are starting small with a couple of use cases, showing the benefits. The benefits are then getting attention, then others will join in. So this is basically how we can get started.
Okay, so this can be an approach like just use it for a small couple of use cases, or in one department, or in one product, or something, let's say, and then kind of proof that it works. Because we are working with a new concept. When you're working with a new concept, you first need to make sure that those people which are really convinced about the product, that they learn hands-on how to work with it. And once they make their first experiences, they are key knowledge owners of this topic, then you need to make sure that you can replicate. So you need to start building up knowledge. Okay.
This can only be done in specific use cases and scaling up.
Good. Then the next questions. What implications does it have on regulation, GDPR, if you start taking the monolith apart and share data throughout the organization? Isn't it a possible risk?
I don't see that there is, in both aspects, there is a risk, because GDPR is giving us a really strict regulation around it. And I don't see any benefits of having it centralized versus decentralized. You always need to make sure that you follow the GDPR guidelines. And I would actually argue that in a monolithic platform, it's more challenging to follow all the rules, because business probably knows exactly what GDPR means applied to their domain, versus if you centralize it, there's so many things mixed together. And by mixing 10 things together in a monolith, you probably rather end up violating GDPR than having it really decoupled. So for instance, if you're working with marketing data, I'm pretty sure that the marketing department exactly knows how to follow GDPR, because the marketing department knows what's inside their data. I'm not sure about if you centralize it, because a centralized IT department might just take the data and say, I don't know what's inside. I'll do my best to check it, but I'm not really sure. So I would say probably a decentralized approach is actually better for handling data in a GDPR compliant way.
Okay.
But I don't see much impact of, you need to be GDPR compliant, and that's not negotiable. So GDPR
you anyways can't go around it. So that's the way we have to go.
Yeah, there's no way to go around it.
Then is this webinar being recorded? Yes, you can actually watch it afterwards on the stream again, or on the WeAreDevelopers platform. And then last question from Mark. I think it's actually a comment. He says you have some really good points. Actually, it's about to not make things too complex, but just focus on what you want to achieve in the business and product, which I think maybe is a good thing a sentence to wrap this.
Great, Mark. Thanks. This was basically that's what I wanted to say.
Yeah. Okay. So this was the last question. Is there anything else, Mario, that you would like to share with the audience?
No, nothing from my side. Just feel free to contact me on LinkedIn. As long as it's not a sales request, I'm pretty happy to discuss everything. And feel free to get in touch with me.
Okay, then Mario, thank you very much for your presentation. I hope to see you again in the future. For the others, for the audience, please take the chance, connect with Mario on LinkedIn, ask your questions about data mesh. It's a very interesting topic and definitely will follow us in the future as well. We are going in a short 7-minute break before we start with our next talk. It's about machine learning for software developers and knitters. So looking forward to seeing what is behind this title, and yeah, take your time, grab a coffee, and see you in a couple of minutes again.
Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential. UiPath, reboot.
Welcome back, everyone. I am here with Chris. Chris is joining us from Munich. Nice to meet you.
Grüß Gott, I believe is traditional to say.
Okay, I just learned that Chris moved from Australia to Munich a couple of months ago, but her German is already perfect. Nevertheless, we will do the presentation in English, right?
Yeah, but I thought I would just do it in English, that's sure.
Yeah. Okay, that's a good idea. Chris, it's so nice to meet you. You are a developer relations manager at AWS, right?
That's right. That's right.
Okay.
I'll talk a little bit more about that in a second.
Perfect. And tell us maybe upfront what is awaiting us in your presentation.
Well, I do not have a machine learning background, but I've always been interested in it. And I thought I would do a project that combined my two passions of playing with things on the internet and knitting. I am a knitter, or stricken auf Deutsch. Ich stricke. And so I'm going to show you a very interesting little machine learning project that attempts to combine the two.
Okay, that sounds very interesting. I would say I will not steal any of your time more. So just go ahead and the stage is yours.
Thank you. Thank you so much for having me. I'm really excited to be here at WeAreDevelopers. My name is Chris, as you heard. You can tweet me at web_goddess, which is up there in the corner. And as you just heard, I'm still relatively new to Europe, to the region. I moved to Munich last year from Sydney, Australia, about 8 months ago. Yes, my husband and I thought it was a great idea to relocate internationally in the middle of a pandemic, but that's a story for another day. So I've been working at AWS for 3 years now. First as a manager in the solutions architects team back in Sydney, and now as a manager in the developer relations team. So over the course of my career, which without giving away my age, has been a couple decades, I started out as a web developer back in the .com boom, building a lot of e-commerce sites. I was a business analyst. I've obviously been a tech evangelist, and even a people leader. But one thing I have not been, my friends, is a data scientist or a machine learning specialist. It's a topic that's very interesting to me, has always been interesting to me. Maybe like you, over the years, I attended a lot of talks at meetups, at conferences, looking for, something that would inspire me, that would show me how to get started. I remember actually a few years ago, I went to a developer conference in Sydney and saw a session called Machine Learning for Software Developers, just like this one. And I got in there and I was so excited. And within 5 minutes, it was nothing but slides of calculus, I swear. And nothing against calculus, but I haven't done calculus since uni. And I just remember looking around at everyone else and we're all looking at each other like, this guy tricked us, So I promise you, there will be no calculus in this session today, no tricks. Instead, I want to have a little bit of fun. I want to show you this project that I've been working on and hopefully inspire you to get started with some machine learning demos of your own. So this is what we're going to cover. So I'm just going to take a few minutes to show you some of the cool stuff that people are doing with AI and machine learning right now that's personally really exciting to me. I'm going to talk a little bit about why I think you should care about machine learning, regardless of what role you're in now. I know a lot of developers think, well, I'm not building machine learning apps, so I don't need to know. But I think everyone's going to need to know, and I'm going to show you how you can get started. I'm going to briefly cover some of the different services we have at AWS that cater to different levels of machine learning expertise. You don't have to be an expert to get going. And then I want to show you that project that I mentioned, which is my attempt to teach a computer to reverse engineer knitting patterns. Seriously. And don't worry, you do not need to know anything about knitting for it. Okay, so let's get started with the magic of AI and ML. It seems like every week there is some new breakthrough, you know, from autonomous self-driving cars to dancing robots to a neural network that defeats the world champion in the game of Go. One that is particularly relevant right now to us in this time is the success of AlphaFold 2 at the 14th annual CASP competition. So CASP stands for Critical Assessment of Techniques for Protein Structure Prediction. That's hard to say. And this actually just happened last November, like 6 months ago. So at this competition, the goal is to predict a particular protein molecule, to predict the structure of it that's made from potentially very long chains of amino acids. And so if we can know the structure, if we can predict the structure, that actually enables a wide range of scientific and medical breakthroughs. And so what you see in this picture here, the actual molecule structure is in green, and the predicted structure, the AlphaFold 2 structure, is predicted in blue. So it's pretty close. And incidentally, that depicted protein happens, of course, to belong to coronavirus and is implicated in immune evasion. So machine learning is very much contributing to fighting the pandemic that we're all living under. Another area that I personally really love, and you might guess since I'm going to talk about knitting, is using machine learning to create art. And back in Australia, I actually organized an entire one-day conference about this, with sessions about procedurally generating landscapes. We talked about NaNoGenMo, National Novel Generating Month, which happens every November, where the goal is to write code that will generate a 50,000 word novel. And so one of the techniques, the first techniques in machine learning that artists really jumped on back in 2014 was called Deep Dream. So the basic gist of it is, let's say you have a neural network represented by this diagram here, and you've trained it to recognize different animals and objects. So you see those output classes on the right: dog, cat, mouse, bear, wolf. And so the idea is you feed in that cute picture of a puppy as the input on the left-hand side. And so when you feed in the puppy, you expect the output neuron corresponding to the dog class to fire. So that's why the dog label is lit up with yellow. Suppose, however, instead of a puppy, we give it a picture that it hasn't been trained on. Let's say a jellyfish. So obviously, we're not going to get the output class for the dog to fire. But now what happens if we start making a series of modifications to our original input to try to get the dog neuron to fire? And so very quickly, after just a few iterations and alterations, you start to get recognizable dog parts like snouts and legs, and they're really surreal and dreamlike and beautiful. I love this stuff. Another one that sort of went viral in 2016 was neural style transfer with that Prisma AI app. You probably saw it all over your social media. So the technology basically separates out artistic style from the content of the image underneath. It's like you can copy the style from one image and paste it onto another one. So these are some images that I actually generated myself at a TensorFlow workshop back in 2017, starting from a photo of my husband and a horse, and applying the styles of a few different famous paintings. And personally, I really like that first one. Another big breakthrough for artists, and you've probably heard the term GANs, Generative Adversarial Networks. And this is where a system can learn to generate realistic looking images that don't actually exist in real life. The very famous example is These People Do Not Exist, I think it's called, which is images of human beings. But this is the internet, let's talk cats. The website's TheseCatsDoNotExist.com, which is a real website. It was built using the now popular StyleGAN on Amazon Sagemaker. And I'm going to talk a fair bit about Sagemaker later on. But some of the images that come out of this are virtually indistinguishable from reality, while others are maybe a little bit more frightening. You don't just have to use GANs to create photorealistic output, though. This one here is a piece created by my friend Jay Rosenbaum back in Australia. Jay is a Melbourne AI artist and researcher working with 3D modeling, AI, and extended reality technologies. And so Melbourne, you may know, went into an extended lockdown last year due to COVID. And so during the lockdown, Jay created these artworks, starting with drawings of faces and bodies, and then used a GAN to generate landscapes from the sketches. And the artwork's called The Isolation of Being. I think it's very pretty. And just one last machine learning use case, the one that I personally love the most, getting pizza to people faster. Domino's Pizza Enterprises Limited is the largest Domino's franchise holder in the world. They represent Domino's in 9 countries, including here in Germany, where I live now, and in Australia, where I used to live. So even before the pandemic, Domino's knew that more than 70% of their sales were coming through online orders. And they worked out that the sooner that they could get a pizza to customers, the happier the customers were with their meal. Of course, makes sense. So in 2019, they launched Project 310, which was an initiative that aimed to have a pizza ready for pickup within 3 minutes of ordering it, or safely delivered within 10. So they achieved that through more efficient cooking methods and transportation, obviously, by opening more stores closer to where people live, of course, but also using predictive technologies to help reduce pizza making and delivery times. So the system they implemented uses Amazon S3, that's our simple storage service, as a data lake, and Amazon Sagemaker to build machine learning models. So basically the restaurants that have this have like a heads up display that shows the likelihood of certain pizzas being ordered at any given time. And the people there can actually start making them ahead of time. So they're sliding out of the oven just as you're calling up to place your order. And at one store, they actually managed to get delivery times down to just 5 minutes. So how is this relevant to you? I honestly can't believe you'd be asking that, given that I just told you about getting pizza faster. But I know that sometimes traditional software developers think this all sounds neat and super complicated, but not really something that impacts them in their day job. What I want you to understand, at AWS, we believe that in the fullness of time, virtually every application is going to be infused with artificial intelligence and machine learning. Most of the customers we're talking to are really interested in this areas, and not just the ones you expect. Financial services companies, of course, but also startups, SaaS providers, retailers, media companies, even nonprofits. And we're really only at the beginning of this revolution. So for the sake of your own career, I'm telling you, you need to develop an understanding of these technologies. This is a quote I really like from Chris Bishop, who's a top AI researcher and academic in the UK. So there's been this idea floating around for the past couple of years, a sort of paradigm shift in software development called Software 2.0. And the quote really summarizes it. For the last 40 years, we've programmed computers. For the next 40, we will train them. So in other words, instead of writing exact instructions to a computer, we're going to start training software to customize itself to different users and use cases. So instead of writing something once, cloning it, and running it everywhere, we're going to move to writing it once and then train or adapt to create many customizations. But also, instead of building code out of precise functions as building blocks, we're going to move to functions that don't always produce exactly accurate results every time. And that means you need to know how to handle that. Just to give you an example, this is a code snippet that can be used, it's Python, that can be used to invoke Amazon Textract. So this is an AI service that we have where you feed in an image with some text in it, and it will actually retrieve the text for you. So in this case, the component that we're invoking has already been pre-trained. You don't need to train the model yourself. But unlike invoking a function that always, that's guaranteed to return predictable and accurate results, instead, you're going to get confidence values. You're going to need to examine confidence values returned by Textract and then branch your logic based on the level of confidence. So in some ways, this is similar to how you handle exceptions. Do one thing on success, do another thing on failure. But in this case, the outcome isn't binary. It is a spectrum of possible confidence levels over the results that you're going to need to deal with. So look, that's just a little bit of my argument that regardless of the code you're writing today, I really think all of us can benefit by getting a basic understanding of how this works. If you're just starting out with machine learning and you want to know how to get going, one resource that I can really recommend is AWS's Ramp Up Guide for Machine Learning. This is a free download. It's on the website there at the URL. It links to free resources and training courses that you can start building up your skills. Also, back in February, we held an event called AWS Innovate, which was an online event with more than 50 sessions with latest innovations, key concepts, use cases, best practices. And so if you Google AWS Innovate, you can still register and watch all of those sessions on demand. I just want to briefly just outline the AWS machine learning stack, just because we have a lot of different tools and it's growing all the time. From the start, our mission at AWS has been to put machine learning in the hands of every developer. So how do we do this? We do this by building many different AI/ML services that cater to different skill levels. And I know it looks like there's a lot here, but these services can be roughly positioned in 3 different layers. We've got frameworks and infrastructure at the bottom, we've got machine learning services in the middle, and we've got AI services at the top. And so I'm just going to go into those a little bit just so you understand what they mean. So that top layer, AI services, as we call it, these are where models are largely pre-trained for you. You don't have to train any machine learning models, and predictions are accessible just by calling an API. So these range from image recognition, natural language processing, including both speech to text and text to speech, Amazon Textract that I just mentioned and showed you that snippet of code, even a newly launched suite of anomaly detection tools under the Amazon Lookout brand. You see a lot of new there because we had a lot of announcements in this space at reInvent last year. In the middle layer, which we call machine learning services, this for the most part means the various functionality of Amazon Sagemaker. So this is where we offer an integrated development environment and IDE called Sagemaker Studio with all the tools that you need to develop, train, debug, tune, deploy, and monitor your machine learning models. And again, lots of new labels on there because we introduced a whole raft of new features back at reInvent. And finally, if you're an expert, if you know this stuff and you want to roll your own, we have the foundational options there at the bottom in the frameworks and infrastructure layer. Because here, if you're a competent practitioner, you can launch a deep learning machine image or container on whatever powerful hardware you want. You can manage the infrastructure how you like. And I'm not going to be demoing that part because, again, not a machine learning expert, but I will be talking you through a couple of services at the middle and the top layers. That brings us to my project. I've called it KnitML, but yes, whenever I'm not messing around with computers, I'm often knitting. And just in case English is not your first language, what I mean by knitting is this. Auf Deutsch, stricken, you have 2 needles, you have some wool, and you make something. I'm currently knitting a vest for my husband. I took up this hobby a long time ago when I first moved to Australia. I've been doing it off and on when I usually keep it by my computer when I'm in a long meeting. I can get a few rows in. And because people in tech know that I'm a knitter, sometimes I get tagged on tweets like this. So this is a real tweet that someone tagged me on back in April. And it turns out this poor guy's mother turned one of his favorite pullis, his favorite pullovers, into a cushion for the sofa. And he wanted to see if anyone could recreate his original jumper from a photograph. And of course, in the replies, somebody joked, oh, there's got to be an app for that. But actually, for an experienced knitter like me, this is a pretty common and easy thing to do. This is a photo that I took back in 2019 in the AWS Sydney kitchen. This is my colleague, Mega. She was sitting next to me having lunch, and she had this beautiful blue jumper on. And I'd never seen that stitch before. And so I took a photo of it because I'm a knitter and I'm weird, and that's what I do. So by looking at this photo, I and any competent knitter could tell you that the background there, the background stitch is reverse stockinette stitch. And those raised zigzag lines, those consist of 3 knit stitches, and they use a combination of increases on one side and decreases on the other to make them lean. Now, some of that I get just because I can recognize the texture of what reverse stockinette stitch looks like. But if I have a good enough image, I can actually zoom in and read it stitch by stitch, like reading cursive handwriting. So you and I know that this is reverse engineering. This is taking a human-made object and studying it to deconstruct its design and its architecture. And we use that term a lot in software engineering, but in case you didn't know, knitters love doing it too. So that's what got me thinking. if a skilled human knitter can reverse engineer a pattern, can identify a stitch, can work out a pattern from a finished sweater or even just a photograph of a finished object, why can't I train a computer to do it? So I started researching this topic a few years ago, and what I found out is that other people had this idea too. Bet you didn't expect to see a scientific white paper and a talk about knitting, did you? This paper was presented at the International Conference on Machine Learning in June 2019, so just 2 years ago. And so this is from some researchers at MIT in the US, and their goal was to take a photograph of some knitting, of a piece of knitting, reverse engineer the pattern with machine learning, feed that into a knitting machine. There are big industrial knitting machines. You don't have to knit everything by hand. And hopefully get an identical swatch back out. So swatch just means a piece of knitted fabric. So basically they want to build a knitting duplicator. Like, how sci-fi is that? So they recognized early on in the project that photographs of knitting kind of suck for computer vision, to be honest with you, because knitting is floppy. You know, it's floppy, it's stretchy, it's often fuzzy depending on what wool you use. So the real breakthrough they had in this project was they had photographs of real knitting, but they also augmented that with simulated knitting using the software from an industrial knitting machine. As I mentioned, those industrial machines come with very specialized software that can actually, pre-visualize what knitted fabric will look like. So they used that to augment their training data and realized that by including both of those things, they got much better results. Now, this paper has a lot of calculus in it, and I promised you we're not going to show any calculus. And honestly, I don't understand a lot of it. But if you read it, what you get from the results is they didn't quite crack it yet, but they're getting close. They got to about 80% accuracy in their experiments using both convolutional and generative adversarial neural networks. So no, there is not yet an app for this, but we're getting there. And that's why I decided I would give it a try myself. But rather than focus on reading a pattern stitch by stitch, which was essentially what they were trying to do, I decided to treat it as an image classification problem. So image classification it's like that diagram I showed you with the image of the puppy. We're going to take an image as input and then output a class label for it. So similar to how I could look at that picture of Mega's jumper and know from the texture that that was reverse stockinette stitch, I wanted to see if I could build a machine learning model that would do the same. So I got a piece of paper and I wrote down my plan. Here's the plan as I saw it, not having a background in machine learning. I'd just get some training data. How hard could that be? I'd label it. I'd train a model, deploy it, maybe build a nice, web front end, just to make it pretty for inference, and dance on the grave of the knitting industry, right? Like easy peasy. I'm sure you can see how this is going to go. Step one, get training data. The first thing you learn that everyone tells you when you start playing around with machine learning is that you're going to spend 80% of your time getting clean data. It's the hardest part. It's where you're going to spend the great majority of your time. And there are a lot of data sets available when you start doing machine learning projects. Kaggle's a great source for data sets. There's various data sets available. Not a lot of knitting data out there, but I did do some research to see what others had done. So that paper I mentioned from the researchers at MIT, they actually do make their images available. So just to show you a little bit into their methodology, they used one of those industrial knitting machines to knit about 1,000 pattern samples in 5x5 grids. And the reason they did those grids was very clever. To keep the tension regular, because I mentioned, knitting's floppy and stretchy, they inserted steel rods into the grid to keep it nice and flat and even so that they could photograph it. But they realized very quickly that this was not going to scale to the amount they wanted for their training set. So that's when they hit upon the idea of using simulated knitting as well and combining that. But they have made their photograph data set available. You can go to the website and download it, and I've downloaded it and played around with it. But I decided that their approach was a bit overkill for me. Really, I decided to just focus on whether I could identify 5 basic stitches: stockinette, reverse stockinette, which is the back side of stockinette, garter stitch, moss stitch, and seed stitch. These are 5 very basic, just combinations of knits and purls. And since I am a glutton for punishment, I decided to crowdsource my own data set directly from knitters, because there are so many thousands of knitters online. You probably don't even know the Venn diagram of knitters and computer nerds. There's a lot of overlap there. I didn't, however, want to spend hours like scraping images of knitting off different websites and then re-uploading them for my training data. Instead, I wanted to automate as much as possible. And so the first thing I did was actually set up an email pipeline. I'm not going to go through this in detail, but the idea is that I'd have an email address that people could email with attachments with their photographs of knitting. I would check that for viruses, and then I would save the attachments directly into an S3 bucket. As I said, that's Amazon's simple storage service, because that's where I knew I was going to need them for my training jobs. And that saved me having to handle every image individually. So I used a few different services here to set this up. Amazon's simple email service for the email address and processing. I used AWS Lambda, which is this is an event-driven architecture. So when an email comes in and goes into the S3 bucket, the Lambda picks it up, it saves the attachment in another bucket, and it logs the metadata from the email into a DynamoDB table, which is our NoSQL database, so I could keep track of who to email me. So I got it ready, got it all set up, didn't take long, tested it. And then it was time to put out the call. So this is a tweet I made in October 2019 asking for knitted samples. So I actually wrote a little blog post explaining exactly what I was looking for, the type, up close, the 5 stitches I was after. I talked about what I didn't want, and I shared the email address so that people could send them in. And I posted this in a few places. I put it on Twitter. I also put it on Ravelry, which is GitHub for knitters. If you're not familiar, it's like the place for knitters online. And the great news is it kind of went viral. I got retweeted like more than 350 times, and people started tagging their knitting friends and forwarding it to them. And the amazing thing is that images started to arrive in the S3 bucket. Random human beings around the world saw my request and were helping me out with my project. You know, just so much love for humanity. And then I looked at the images, and some of them were great. But others, yeah. Sometimes people were so excited to help that they didn't read closely. You know, they sent me stitch patterns that I wasn't looking for, or pictures of whole garments that didn't have the resolution so that I could see the stitches, or even attached by accident the wrong images altogether. So the first lesson of crowdsourcing data is that it's going to result in a lot of cleanup. And I'm not shaming these folks. I really am super grateful for them. They were being generous and trying to help me out. But if you're going to crowdsource your data, just know it is not going to save you from having to still clean it out, all the images up yourself. So I persevered. I went in, I threw out the dodgy images. I cropped the rest that I could just to show the stitch pattern. And then the next step was to get the images labeled. Rather than me going through and labeling these myself, that this is garter, this is stockinette, this is seed, I again turned to my fellow knitters. So one of the services we have in that middle layer, the machine learning layer of the AWS stack, is called Sagemaker Ground Truth. And that helps you build highly accurate training data sets for machine learning by coordinating private and public workforces. Basically, it's like a UI where you can set up a labeling job, and then you can recruit your own people to go in and label, or you can use Amazon Mechanical Turk and actually pay strangers a few cents. Because this is kind of a specialized skill to know which stitch it is, I didn't want to do that. So I recruited my own volunteer task force, and I set up the job. So what I'm going to do now is actually switch over to my browser and show you what this looks like. Okay. So this here is Sagemaker Ground Truth. And I've got a few labeling jobs set up. So I'm just going to open one of them here and view the labeling tool. In case you haven't seen Ground Truth, this is what it looks like. So I wrote some instructions. You can customize it yourself. So you can see on the left there, I've got some instructions showing people the different stitches we're looking for. And then basically it presents one of the images from my training data set, and they have to select the option that it applies to. As you can see, I've got stockinette, garter, seed, moss, reverse stockinette. Those are my 5 labels. And I've got other, which is the one for something that isn't any of them, just in case any of them slip through. So this one, for example, is stockinette. So I had a whole bunch of volunteers doing that for me. And pretty quickly, I realized I was going to run into some issues. So the first problem I discovered, on the left here, you see garter stitch. Okay, that's what you get when you knit every row. No purling, just knit, knit, knit. On the right there is reverse stockinette stitch, which is the back side of stockinette. And that's where you knit one row and then you purl one row. And so this is the purl side of it. And what do you notice from these two? They look an awful lot alike. In real life, they're very easy to tell apart because you can just flip it over. One of them's the same on both sides and one isn't. But in a photograph, I hadn't actually anticipated this. They're kind of indistinguishable. Some photos are easier to tell than others, but I personally had a hard time labeling them in the tool. And so I realized that my labels for that one are probably going to be not going to be as accurate. I did set up the training job. You can set some thresholds in ground truth. I set it up so that every image had to be labeled at least 3 times, just so that I accounted for individual label error. Another problem I had, so 2 of the other stitches you'll recall that I was using were seed and moss. And I thought, oh, these are super easy to tell apart, not a problem. So you can see from the photos here, very different. Then I discovered that in British patterns, they use both words to refer to the same thing, the image on the left. Only Americans call the one on the right moss stitch, which I hadn't accounted for. So again, those labels are going to be pretty inaccurate and unreliable. So this is when I realized I was going to have to do scope even further. And I thought, okay, how simple, what is the absolute simplest I can go? Let's see if I can identify just a single stitch pattern. You all know the joke from Silicon Valley, right? Hot dog or not? I decided to do stockinette or not. Is it stockinette stitch or not? That's what we're aiming for. So then it was time to train the model. And so back in 2019, when I was first doing this demo, when I started doing this, my best option for this was Amazon SageMaker. So as I mentioned, SageMaker is a fully managed service that covers the whole machine learning workflow. Now, rather than using Jupyter notebooks or anything like that, I actually just set up all my training jobs directly in the console because remember, not a machine learning expert. I ran my training jobs on a single P3 2 extra large instance, which is an instance type that has powerful GPUs to accelerate machine learning jobs. So I will now switch over and show you what this looks like in SageMaker. All right, so going back to my browser here, where's my mouse? Firefox. Okay, Firefox. So this is SageMaker, and you can see it had ground truth built in, but if I go down here to training, here are my training jobs. And to set up a training job, I'll click the button to create a training job. You give it a name, you give it a role. There are a lot of options in SageMaker. But the basics that you need to provide it with are an algorithm, and there's a whole bunch built in that you can choose from. You need to tell it what sort of resources you want to use for your training job. You need to tell it where the training data is. So point it at your S3 bucket. And really what you want to do is you want to give it training and validation data. So normally you carve off 80% of your training data, of your data for training, and you save 20% and you use that afterwards, and it tests the accuracy of the model on that. So you point it to where it can get that. And I use the output from ground truth. Ground truth creates a manifest that's got all the labels and everything you need. So you can put that in, you tell it where you want it to put the output, and then you kick it off. And so if I show all my training jobs here, let's do all of them and scroll down to the beginning, you'll see that it took me 7 jobs before I got one that actually completed, because I was always getting something wrong or missing a key flag. But eventually I got one that worked. Yay. It took 23 minutes for this first training job. I had 360 some images. So once you have your model trained, then it's time to actually deploy it. And so to do that in SageMaker, if I go down to Inference, I need to first take my training job and create a model. So if I click on that training job, I can click up here to create a model package. And so if I go to models in the UI, you'll see I've got several models, 3 different models in there that I created. So you create a model from the successful training job. Then you need to create an endpoint configuration. And then you actually set up an endpoint, which is where you're actually hosting the endpoint that you'll call for inference. So let's actually now go back to PowerPoint and see what this looked like. Okay, so we did training, deploying. I talked to you about Sagemaker makes it really easy. That's honestly, that was the whole easiest part of it, just setting up that endpoint configuration. Takes a few minutes for the hosted endpoint to be created, and then you can start passing images to it and hopefully getting the right classes back. And then I mentioned to you, I wanted to build something pretty to show it off, you know, to have a little web front end, because I wanted to, of course, give this talk at meetups and conferences. And so I wanted a web front end. And so one of my developer advocate colleagues, Gabe Hollenby, shared a little React web app that he built. And so I got that running. The only tricky bit you need to know is that Sagemaker endpoints aren't exposed to the public. So you need a Lambda function in there as the intermediary. And we have a blog post on the AWS blog about using API Gateway and Lambda to do this. But once you get that set up, I fired up the little React app. I pointed it at my endpoint and I dragged in the first image, a close-up of stockinette Stitch. And, oh my God, stockinette Stitch. This is actually correct. I've cracked machine learning on my first try. Where's my PhD? I thought maybe I'd drag in just another image just to be sure. That's not stockinette Stitch, that's garter stitch. That's not good. All right, well, how about another one? That's not even knitting, that's crochet. That's where you use a single hook. It's a totally different craft. That's not good. So by now I sort of was having a very sinking feeling in my stomach. I dragged in one more image. That's a cat. That's not a knitting at all. That's a cat. So cancel the PhD. It turns out this is often the case with machine learning. It is extremely unlikely you hit the jackpot on your first go. So I went digging in my logs and I found that my validation accuracy was 45%, actually worse than a coin flip. So it was time to go back to data cleaning and more training. And I ended up running, as you saw, a lot of training jobs, more than 15 different training jobs, trying to find the magic combination that would give me the best result. So to minimize the effects of image size and color, I cropped them all to a fixed size and I made them grayscale instead of color. I also rotated each image 90 degrees, which is a neat trick because it doubles the size of your training data set. It meant I had a lot more images just by rotating them. I also added in clutter. This was something I learned about. The idea is if you train the model on all images of knitting and then you give it a picture of a cat, it's going to think the cat is knitting because knitting is all it knows. So I needed to add in images of other stuff. So I added in dinosaurs and accordions and airplanes just to provide more examples of things that weren't knitting. I also ran a hyperparameter tuning job, and that sounds really, really fancy. But the idea is instead of like manually trying out thousands of combinations of tweaking all those hyperparameters in a machine learning training job, Sagemaker makes it really easy and it'll do it for you. You can set up a tuning job and it will run and try out hundreds of combinations and find the one that works best. So I did all of that. I cleaned up my images. I added in clutter. I ran a hyperparameter tuning job. And let me show you the best results that I managed to get back in 2019. So I have here, this is my little front-end inference app. And I will open up, I have here some test images. So I'm going to drag in a stocking stitch image. Just dragging that in. And voila, stockinette stitch, 95%. All right, let me drag in a garter stitch. Not stockinette stitch. This is looking much better, my friends. How about the crochet? Let's see what it does with the crochet. Some crochet, not stockinette stitch. And of course, our friend. We now know that the cat is not knitting, so my clutter worked. It's not just black and white images as well. So when I did this at a conference, I actually went around and took pictures of people's jumpers. So I can show you with some real close-ups taken with my phone of people's sweaters. So I'll just drag a few in here. So Ben's jumper there, that first one is not stockinette, that's correct. This one with the snowflake is stockinette, but it was only 50% accurate. So I wasn't quite sure on that one. This is one of my own jumpers, that's stockinette stitch, and it comes up as stockinette stitch. The one that it gets wrong reliably, it's not 100%. The one it gets wrong reliably is this one. This girl, Paulina, had a jumper. It thinks is stockinette stitch. And I can kind of see why. Stockinette stitch results in these sort of characteristic V's. And you can see that in that image. And that's why it's tricking it. I don't actually know what stitch her jumper was, some sort of interesting brioche or something, but not stockinette. So it's not 100%, but it is pretty darn good. And so I will show you my stats here now. Going after adding in all those images, cleaning them up, rotating them with hyperparameter optimization, my validation accuracy is now up to nearly 95%, which I was thrilled with considering I am a complete newbie at this. So this is where I stopped back in 2019. I was like, great, yes. Hey, I've kind of proved I can tell stockinette stitch or not. But as you know, AWS is always innovating. And literally a month after I finished this project, we announced the availability of recognition custom labels. So recognition is one of those services at the top level. It's one of our AI, pre-built AI services at the top layer of the stack. And out of the box, it allows you to identify common objects, celebrities, text, scenes, activities, and images and video. It just works. But it doesn't recognize knitting, of course. There's various domains it doesn't have built in. So with custom labels, you can now build your own specialized image analysis capabilities to detect specific images for your use case. And you don't have to train a model from scratch. You can get started with just a handful of images. So I thought, why not put the two of them head to head? So see how it compared to the model that I built with Sagemaker. So I have here the console open, and this is recognition custom labels. So it's so much simpler to use. So to create a new project, just create that button and give it a name. All a project consists of are data sets and training jobs. So under data sets, let's create a new data set. So we'll call this WeAreDevs. You give it a name. You say where you're pulling the images from, which can be an S3 bucket. You can pull in from a ground truth job. So I was able to just use the output of my old ground truth job right away. Or you can even just upload from your computer. So I'll click that, click submit. And so now I can actually start adding images directly from my computer. I will drag some in. Let's go here and just drag in a few images. No, I have to click add first, then I drag them in. Yeah. And so it's going to upload these. And then recognition custom labels has a built-in UI. I don't have to use ground truth. It's actually got it built in. So once I've added some images, and you only need 10 per label to get started. So this is as quickly as you can go. Now I need to set up a label. So I'll click add a label and create a label called stockinette. Okay, and I'll create one called other for anything other than stockinette. Hit save. Now I can actually label these. So this first one, I can just assign a label, stockinette. And so you can very quickly upload your images and get them labeled. You can also draw bounding boxes if you want to try and identify things within the image. So super quick to build up your data set. So I'll go back to my project. So once you've got a data set, you can actually then go to one of these custom labels 3, you can just click the train a model button and it will start training the model for you. So here is one of mine where you can see the output of the train. You can see here's some of my clutter. You can see I've got the labels on it. And then to actually test this out, you can just you don't have to worry about hosting an endpoint, setting up an endpoint configuration, all of that out of the box. Recognition provides that for you. I was able to, on our GitHub page, we have a demo here called Amazon Recognition Custom Labels Demo with a CloudFormation stack that you can just click and it will automatically set up in your account this really cool web app where you can demo recognition custom labels endpoints. So I've got here 3 different models running, and we can test it out. So I did, for the first one, do just with 10 images, like the bare minimum. And so if I test this out now, so I'll upload stuck in at stitch, and it gets it wrong. It thinks it's seed stitch. So using only 50 images, it was not enough to get a good result. The second one here, this is the one that was the same as SageMaker. So this is the same model, and I get 99% accuracy on that. I get, let's put in some weaving here. It thinks weaving is stockinette, so it's not 100% perfect, but it gets all the rest of them. It knows that that moss stitch is not stockinette. It knows that the cat is not stockinette. So I'm like, hang on, this looks very comparable to what I got out of SageMaker. And actually, it is. I'll show you when I go into my logs, but the accuracy was very comparable. I did do one other model. I did one more model where I actually went in to see if I could get it to pick up more than just stockinette or not stockinette. So with this model, I actually, I now can tell moss versus seed stitch. So because recognition custom labels was so easy to use, I actually went further and created more training jobs, which get me even more accuracy. But now I'll show you my stats. So again, this is comparing like for like with the SageMaker job with 900 images. It's comparable. It is almost the same. In fact, it might be a little bit better. They don't use the exact same metrics. Recognition uses slightly different ones that are derived from the ratio of false positives and true positives. It gives you this F1 score, but it's roughly comparable. They're very similar. And I've done here a slide just showing you to compare the 2 approaches. Just in terms of the data labeling UI, you can use ground truth either with SageMaker or with recognition custom labels, although recognition custom labels also does have that built-in UI you can use as well. In terms of training time, SageMaker took 33 minutes for my first job, but remember, you choose your resources you want to use, and I threw a pretty big instance at it, that P3 2 extra large. And then the actual hyperparameter training job, I let run for 13 hours. So that obviously is very variable. Versus with recognition custom labels, you have a lot less control over the training job. You kick off your training job based on your data set. It decides how many instances to spin up. It decides which algorithms it's going to test. So you don't actually have really any flexibility there. Jobs, we expect most, like 90% of jobs should finish, I think we say in less than 24 hours. Mine finished in way under, most of mine finished in under an hour. I did have one that went to 4 hours. And if anything hits 72 hours, we automatically kill it and don't charge you for that. But you have a lot less control over the training jobs, the recognition custom labels. In terms of cost, this is really where you start making trade-offs, because in SageMaker, you pay for training. There's a cost associated with the instance that you use for training, with provision storage, with data transfer. There is a free tier with SageMaker that gets 50 hours on a couple different instances for training and 125 hours for inference on an ongoing basis. Versus the costing for recognition custom labels is much simpler. It's $1 an hour for training and it's $4 an hour for inference. But as I said, you have a lot less control over the length of the training job. So that's out of your hands. And in terms of inference, you don't want to use this for something that you leave on all the time. You want to use it for something that you do in batches. So you turn it on, run your inference, and then turn it off just to optimize your cost. Oh, and the other thing I should have mentioned on SageMaker is you can use spot instances, which can save you a lot of money. So I think probably for an ongoing basis, SageMaker is probably a cheaper option. But for me, given the results and the ease of use there, recognition custom labels gave me comparable accuracy and was so much easy to use. You do not need to have someone who's a data expert. And bear in mind, I did run that SageMaker example 18 months ago. So nowadays with someone who's an expert, that accuracy could probably be even higher on SageMaker if you're an expert. Just one last thing to mention, you don't have to take my word for this. This is a blog post from last November from Luca Bianchi, who's an AWS serverless hero in Milan. And so Luca did the same thing I did, built a model with Sagemaker and then did the same one again with recognition custom labels. So his use case was snapshots from HVAC systems, that's heating and air conditioning systems, checking their cleanliness. And so he had a data set of about 2,300 images. He used SageMaker with PyTorch and FastAI and did all the expertise, expert machine learning stuff and got an accuracy of around 92%. He then took that data, fed it into recognition custom labels, and found that it gave comparable accuracy. He called it mind-blowing. You still need to do all the work, obviously, of preparing your training data, your training images, but you do not need that dedicated data scientist to set this up. And this kind of use case, using it for this kind of use case is ideal because, yeah, you do it at the end of the month. You spin it up, you check all your images, and then you turn it off again to optimize costs. Just want to give a few quick thank yous to all the knitters and all the people who helped me with my project. So 53 knitters from around the world sent images to me. A team of 14 human beings were my labeling task force and spent a whole lot of time clicking buttons thousands of times. And I also had some wonderful advice from colleagues at AWS like Aparna Alangavan and Gabe Hollenby. So just to recap, we talked a little bit about some of the things I find cool about AI ML, some of the stuff that gets me excited about it, like advances in solving, in helping eradicate COVID, in creating art and in getting pizza to everyone faster, which who doesn't want that? We talk about why I think it's important for you to know something about machine learning, even if you don't think it impacts your job as a software developer. Talked about the AWS machine learning stack and how we have different services at 3 different tiers, depending on your level of machine learning capability and knowledge. And then I talked to you about my little KnitML project about trying to teach a computer to reverse engineering. And there's no way I'm done with this, by the way. This is going to be ongoing. That's really all I had for you today. I did just want to quickly mention, though, by the way, if you didn't know, we have a new region coming in Switzerland next year. So if you're in region, this might be of interest to you. Check it out. And thank you so much for having me.
So Chris, thank you so much. This was such an amazing talk. I hope you still have some energy.
I do. I have lots of energy. This gives me excitement. This gives me energy.
Perfect, because we have some very interesting questions for you. So let's get the questions on the screen. So, first question from David. David, thank you. What algorithm did you use?
In SageMaker, I believe it's just image classification is the algorithm. They have a lot in there. I think I just used the one that says image classification. I can verify that while we're talking.
Thanks. Then let's see if we have a more tough question. There is actually one.
Don't give me tough ones. You know I'm not an expert.
Yeah, but maybe you have some good answers. So Lex is asking, what would happen if you morph 2 knitting images and the cat together into one image? Would it still work or break?
Oh, that's
we need to try this out.
That's a very interesting. There's a really cool knitting and AI project called Skyknit that Janelle Shea did. If you know Janelle's got the AI weirdness blog. And she does things where she tries to use a neural network to name colors or cats or romance novels or whatever. And so Janelle used a neural network to generate knitting patterns and then had people try and knit them. And some of them come out looking like alien things. They're really funny. That's what I imagine you'd get. Yes.
Okay, good. Let's see for the next question. How do you know when the model has received enough training for a useful result? I think this question was asked pretty at the beginning, but
it's a really good question, and I think it's one of the areas that's hard to know. That basically you start seeing a convergence of different where the more you train, you're not getting any better accuracy. So you kind of, with the hyperparameter tuning job, I let it run and I could see that it was pretty much maxing out. And so I stopped it and picked the best one from that winner. I imagine that an expert would tell you that in Jupyter, you can graph accuracy and time and make sure and pick the optimal point. For me, I picked the one that gave good enough. Good enough.
Okay, good. Then a question from Mr. or Miss Anonymous. What other use cases could you imagine with the same code base?
I've seen some great use cases. So for example, that one there of identifying systems, that you need to check periodically, that's a good one. Another one that I saw a talk on back in Australia was from a retailer that sells cars online. People can upload pictures of their car that they're selling. And there's a big problem with people who upload pictures of number plates, of license plates, because criminals print them off and steal them. And so what you want with user-generated content is you want to identify license plates and images and blur them out. So you could, for example, have a daily job or periodically run a job that over user-generated images that would identify number plates, and you'd then identify those and apply some additional processing to them. So really anything where another use case we talk about is if you're like a social media manager and you want to see mentions of your brand, or you want to see if your logo is being used in social media images or news stories, you could train a model to recognize your logo and then feed it data to look for it.
Yeah, that sounds interesting. There's some nice cases. Then thanks so much. Such a nice presentation. What other super crazy projects do you have? Is there anything you want to mention?
Well, so obviously the next thing I need to do is I need to get my own knitting machine, because then, to fully build the replicator, I need to get into the hardware hacking. And this is very much a scene for the knitters and the computer folks. You can get these knitting machines from the 80s. Brother made a bunch of them, the computer printer people. And there are various open hardware projects. There's one called Knittic, which uses a Raspberry Pi to replace the brain in the old knitting machine and allows you to create patterns on the fly and modify patterns on the fly. So I've seen some folks who've done some serious hacking on the knitting machines. That's an area I'd really like to get into.
Okay, sounds interesting. I think we will invite you again to present when it's
maybe in a year on that one. Yeah,
okay. Couldn't you make it a bit faster?
Well, it depends how long lockdown goes, really.
Okay, then I think that's more of a personal question and maybe a bit of a joke, but you can answer at your own risk. So why would you move from sunny Australia to Munich, where it's been raining for the last 2 weeks? In brackets, just joking, welcome to Munich. But
thank you. A lot of people have asked, the movers asked us that as well. I don't think people here realize how lovely it is. On the weekend, the beer gardens are open now. We're sitting in a park having a beer and it's green. One thing I love about Munich is cycling infrastructure. I'm a cyclist as well when I'm not knitting or in front of a computer, and it's flat. You've got great cycleways to ride on. It's a great place to live, and I'm looking forward to hopefully in the next 6 months getting able to travel all around Europe and meet some of you in person. I really can't wait to get to Vienna.
Yeah, coming from Australia, I would say Europe, it's kind of short distances for you, right?
It's exactly. I can do day trips to different countries here, and in Australia, you have to spend a day traveling to get anywhere.
Yeah. Okay. That was actually already the last question. I think everyone enjoyed this talk so much, and I would really hope to see you again at one of our next events, be it live, virtual, in person, whatever. So thank you so much, Chris. Is there anything you still want to share at the end with the audience?
We have our AWS EMEA Summit coming up in 2 weeks from today. So I'll be presenting at that. A number of my colleagues are. It's a free event over 2 days on the 9th and 10th of June. So if you're not registered, just Google AWS EMEA Summit and sign up. You can also watch all the sessions afterwards too.
Okay, perfect. Chris, thanks. See you again in the future.
Yeah, tweet me and show me your crazy machine learning projects.
So, and we are going actually in a super short break. I see it's only 3 minutes, so maybe time for an espresso. And then we are going back live with Håkan and having a nice talk about machine learning in the browser with using TensorFlow.js. And yeah, see you in 180 seconds, something around that.
Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential. UiPath. Reboot work.
Welcome back, everyone. I hope all of you enjoyed your break, even if it were only a couple of minutes. I'm here with Håkan. Håkan, how are you? Nice to meet you.
I'm pretty fine, thank you. Thank you for having me.
Okay, Håkan, where are you joining us from?
I'm joining you from Oslo, Norway.
Okay, does it make sense to ask about the weather?
I guess not actually, no. It's 10 degrees and raining.
Okay. Yeah, then we're anyways in a virtual space, so let's talk about some machine learning stuff. Tell us, what are you going to learn from you today?
Yeah, so what I'm going to be talking about today is how you can use machine learning straight in the browser. Because, usually you need to have a Jupyter notebook and you need to know about Python and other types of frameworks. But with TensorFlow.js, you can actually use it. Any web developer can use machine learning in the browser. So that's really a strength, and the way that you can explore different types of data sets. So we're going to go through two different examples, one where we will build an application from scratch and one where we will use an already existing machine learning library.
Okay, that sounds interesting. I would say we just start right away with the talk. The stage is yours, Håkan. Enjoy it.
Okay, so welcome everyone to this session, which is about machine learning in the browser with TensorFlow.js. So before we start, I'm just going to give you some background information about me. So my name is Håkan Silfvernagel. I work as a manager for AI and big data at a Norwegian consultancy company called Miles. My background is in human-machine interfaces for process automation and robotics. And I'm quite involved in the local user community here in Oslo. So I'm part of the Norwegian.net user group. I'm part of Oslo AI. I'm also a Microsoft AI MVP. And in addition to that, I'm running an online AI school together with Eve Pardy called AI42. So if there is some time left at the end of my session, I will describe the AI school a little bit more. And you can find all my handles on social media on this slide. So now the agenda here for today is, first of all, we're going to go through a little bit about the basics of machine learning, just so that we're all on the same page. And then after that, I'm going to describe the basics of TensorFlow and more specifically TensorFlow.js. And we're going to have two demos. One where we're going to use TensorFlow.js and we'll build an application from scratch. And another one where we'll use an already existing machine learning library called ImageNet. And then we will transform this ImageNet library so that we can use it with TensorFlow.js, and we will build our own image classifier. But first off here, so what is machine learning? Well, machine learning has been with us already since the end of the 1950s, and one of the machine learning's father, called Arthur Samuel, he said that machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. But I can also say that machine learning is a sort of a pattern recognition in historical data. So some ways where we can use machine learning is, for example, prediction. So a classical example here is that you have a house, and then based on how many bedrooms the house has when it was built and what is the location, you can predict the price for this house. Or you can think about the recommendation system, like you go to a web shop and you will get recommended items that people that have similar interest to you has bought previously. Or you can think about clustering. Maybe you have a large set of customers and you want to be able to specify the information to different types of customer groups. Then you can cluster these customers into different groups. Or we also have image recognition and text recognition and speech recognition. So one common way for machine learning is called supervised learning. And the idea here is that we have access both to historical input data and also historical output data so that we know what the result actually was. And then based on this, we can build a machine learning model. And then we can train this model so that it can take real-time data that this model has never seen before. And then it can do either a prediction or a recommendation and give us an answer back. So as I said here in the beginning, I said that machine learning has been with us already since the end of the 1950s. But then the question is, why is it such a big topic today? So part of the answer to that is that we have had a number of enabling technologies that can make this happen. So one of them is that we have access to sensor data that can give us a lot of data. And we also have access to machine learning algorithms in the cloud. And we also have big data solutions so that we can both transform and storage our data. And we have API and services that we as developers can use in our own applications. And now for completeness, I will also mention a little bit about what types of languages we usually use for machine learning. So two of the most popular languages is Python and R. And the difference being that Python is probably more common from people coming from a computer science background, whereas R has historically been more popular at the university and people coming from a statistical background. So now when we covered a little bit about the basics of machine learning, we're going to go dive deeper into TensorFlow. So TensorFlow is an open source library that was developed by the Google Brain team, and it expresses its algorithms using something called tensor operations. So I'll go through more later on what a tensor actually is. And one of the main benefits with TensorFlow is that it supports distributed computing. And that's a huge advantage if you're going to do deep learning or neural networks. So what is a tensor? So a tensor is something that we've taken from mathematics. So in mathematics, you can differentiate between either a scalar, which is just a single real-time number, or you can have a vector, which is like a collection of numbers, or you can have a matrix that's a sort of a two-dimensional collection of numbers. And then a tensor is just a container. So in the tensor, you can contain either scalar or vectors or matrices. And if you use Python, this is the way that you would use TensorFlow in Python. So you import the TensorFlow library, import TensorFlow STF, and then you start up a new session. And then you can define a constant, for example, A with a constant value of 10 and B with a constant value of 32. And then you can perform an operation and print out on the console. So we perform A plus B and we just print it out on the console. But today we're going to be talking about TensorFlow.js. So TensorFlow.js is a JavaScript library that you can use both for training and also deploying your models in the browser and on Node.js. Now we come to the first demo here. So let me switch over here to my browser. One moment here. Or actually, I can switch over to Visual Studio Code. So this is the solution that we have right now here. We have an HTML file where we have imported the TensorFlow JavaScript library, a minimized version. And we have also imported the TensorFlow visualization component, also the minimized version. And then we are referring here to script.js file. So this is where we will build all our application. So we switch over here to script.js. Then we can see that as of now, the only thing we do is we print out hello TensorFlow on the console. So let us just verify that this works. Yeah, so here it just prints out this hello TensorFlow. So then now the question is, what are we going to do here? So we need some kind of data that we will work with. So luckily for us, there is here a JSON file with some data about cars. So in this JSON file, we can find both the name of the car model, we can find the miles per gallon, the MPG, and the number of cylinders and the horsepower and weight and so on. So the main idea here is that we would like to load this data into our application, and then we would like to visualize the data and see if we can find any types of correlations so that we can use this in a machine learning setting. So the first thing that we want to use, we would like to get this car data, the JSON file, and then load it into our application. Let's go over to Visual Studio Code, and then you can define a function here, get data. So what we do is we do fetch on the JSON file, and then after that we will clean the data up a little bit. So what we want to see here is there any correlation between the miles per gallon and the horsepower, and can we predict the miles per gallon for a given horsepower? So what we do is we extract the miles per gallon and the horsepower from our JSON file. And then after that, we filter out the null values because we don't want to have them. And then we return the clean data. And then secondly, we need to have a function here so that we can run this, get data function. So let us define a function over here. So here we define a function called run. So what we do here is we get the data, and then we extract from the data, we extract the values so that we have on the X values, we have the horsepower, and on the Y values, we have the miles per gallon. And then after that, we would like to do a visualization. So here we're using this TensorFlow visualization component in order to render a scatter plot. And then after that, we will build on this and add more functionality to our application. And then in order for this run function to actually run or to be executed, we will define an event listener that is listening to the DOM content loaded event. And when that event has occurred, then it will run this run function. So let us just save this and let us go back here to our browser and let us run this. So we can see here now that without us, we didn't need to write any type of code. We could just use the existing TensorFlow visualization component. And then we got this nice scatter plot here on the right-hand side. And then we can just see here, just by looking at this plot, we can see that there is some sort of relationship between the miles per gallon and the horsepower. So the higher the horsepower, the lower the miles per gallon. It seems like it's a negative correlation. But the important thing here is that there is actually a correlation, because it could have been that maybe all our data points would have been scattered all around the plot. So that would have meant that there is no correlation, or there is no relation for our machine learning algorithm to learn. So this is a good thing, because this means that now there is actually a relationship between miles per gallon and horsepower. So this is a good candidate for machine learning. So next, after that, so here the goal is then that we want to train a model where the input is the horsepower, and then the output or the prediction is the miles per gallon. And what we'll do here is we'll use these values that we have in our JSON file, and then we'll feed them into a neural network. And then this neural network will learn from this example. So then after that, it will be able to predict miles per gallon from a new horsepower value. And this is an example of the supervised learning that we were talking about in the slide presentation before. So the first thing that we want to do here is we want to define something called the model architecture. And that is actually what kind of algorithm should the machine learning model use in order to compute its answers. So in machine learning models, they are algorithms that will take an input and it will produce an output. And in this case, we'll use a neural network. So here the algorithm will be a layer of neurons with different types of weights that will decide what the output should be. And during this training process, the algorithm will learn the best values for these different weights. So let us add a function to our JavaScript application where we can create a model. So let's go back to Visual Studio Code And then let us add, let's add a create model function. So what we do here is we define a model, and in this case, we define a sequential model. So this is one of the most simple models that we have in the TensorFlow.js library. And it's called sequential because its input flows straight down to its output. But there's also much more complex models where you can have multiple input and multiple output and also different types of branches. And after that, we call model.add. So here we add an input layer to our model. And this is connected to something that we call a dense layer. So a dense layer is a type of layer that will multiply its input with a matrix that we call weights. That will also add a number that we call the bias to the result. And since this is the first layer of our network, we also need to specify the input shape, which is 1 in this case. So that means that we have one single number as an input, and that is the horsepower of the car. Now we need to set the units. So that means how big will this weight matrix be for this layer? And here we set it to 1. So that means that there will be one weight for each of the input features of our data. And then we create our output layer here. And here we also set the units to 1 because we want to have one single number as our output, which is the miles per gallon. So next, after that, we need to be able to create an instance of our model. Let me go back here, and then we'll add. So here in the run function, we run the create model function, and then after that, we are using the TensorFlow visualization component in order to show something that is called a model summary. So if we save this and we go over to browser, and then we run this, then we can see here that over here we got a model summary, and this is for people who have used Jupyter notebooks. They are very accustomed to see this model summary. But basically what it is you can see the number of layers, what is the output shape, and how many parameters do you have, and if they are trainable or not. So this looks quite nice here. Then after that, we need to prepare our data so that we can train our machine learning model. So one of the special things here with TensorFlow is that it only works with Tensor as its input formats and output formats. So therefore, we need to be able to convert our data that right now is in the JSON format. We need to convert our data into the Tensor format. So let's add a function here that we call convert to Tensor. If we go back to Visual Studio Code and we go back to here. So here we can see so what we're doing here is we do two best practices here. So the first best practice here is that we shuffle the data. And the reason why we shuffle the data is that when we do the training, we will divide our data into smaller subsets. And these subsets were called batches. And then when we train, we want these batches to be as representative as possible of the whole data set. And therefore, we would like to have the data from all across our data distribution. And then after that, we do another best practice, which is called, actually, I should also say that it also has some more advantages. So one of the advantages with this shuffling is that now we don't run into the risk that we will learn things that are only dependent on the order of the input. And we're not so sensitive to structures in subgroups. For example, you could imagine that maybe for one reason or the other, maybe there's a high horsepower for the first half of the training data. That would be a relationship that would not be representative for the whole data set. And then after that, what we do is we convert our data into tensors by using this tensor tf.tensor2d function. And then we do something called normalization of our data. And in this example, we're using something called min-max scaling. By using min-max scaling, we will have all our data in the range between 0 to 1. And the reason for that is that we want to, because many of these machine learning models internally, they are designed to work with small numbers. So if we do this min-max scaling, we are guaranteed that we will not run into any computational problems. And then finally, we return We return both our normalized inputs and our normalized label. And we also return this mean and max bounds that we used when we did this normalization. And the reason why we return these bounds is that when we're finished, when we got our prediction, we need to be able to somehow transform or convert back our result or prediction back to the original scale so that we can make sense of what it actually represents. So now when we've done that, we need to be able to train our model. So let us define a function here where we can train our model. So here in our function here, the first thing that we need to do here is we need to compile our model before we can train it. And we also need to set some parameters for the compilation. And one of the parameters is our optimizer. So the optimizer is sort of a quality function that will decide on the algorithm that will decide on the updates to the model. So there are many types of optimizers. So here we picked the Adam optimizer because that's one of the most simple and quite effective in practice. And then we need to define our loss function. So our loss function is telling us how well is our model performing and how well is it learning on each of these data subsets or data batches that it will see. And here we've used a function called the mean squared error that will compare the predictions made by the model with the true values. And then finally, we need to pick a batch size and also a number of epochs. So the batch size is how big will this data subsets be. And common batch sizes ranges all from 32 to 512. And there isn't really any ideal batch size for all problems. And it's actually kind of a science in itself to set the batch size. But here we've picked 32 because that's a common batch size that we think will work. And then the number of epochs, we've set that to 50. And that the number of epochs is how many times will our model be able to look at the entire data set. And here we will take 50 iterations through the data set. And then finally, we call model.fit with our input and our labels. And the nice thing here is we can use a callback, and in this callback, we can use our TensorFlow visualization component. And we can print out for each batch, we can print out the loss function and the mean squared error. Yeah, so this is a way that we can monitor the training, and we will be able to plot a chart so that we can see both the loss and the mean square error. So now it's time to actually do the training here. So then we need to call this from our run function. So if we go back to the run function, and then so what we do here is we convert our data into tensors, and then we extract the inputs and the labels, and then we train our model with using our model and then the input and the labels. And then we write on the console log done training when we finished. So if we save this and then we go back here to the browser, then we can see here that here we can then see our loss and our mean squared error. So on the x-axis, you can see the number of epochs. So we set that to 50. And then we would like to have this, the loss value and the mean squared error, have it as low as possible. So we can see now when we reached the end there, we can see that it's 0.05 or 0.6 or something. So let's say that we're happy with that kind of loss function value. Then it's time actually to use our machine learning model. So we want to be able to make predictions. So then we need to generate some new data that our model hasn't seen before. So let us add a function to our application. Let me add it over here. As here, we have a function called test model. So what we do here is we will generate 100 new examples, and we will feed these new examples into our models. And after we've done that, so here's the new examples, and here we call model.predict in order to get our predictions. And then after we've done that, we're using this input mean and input max in order to be able to scale back our predictions to the original scale. So we're doing sort of an unnormalization of data. And then finally, what we do is we will use this TensorFlow visualization component and again render a new scatter plot where we can see the model predictions and our original data. And then hopefully they should be as similar as possible. And after this, the only thing that remains here is that we need to call this function from our run function. And let's do that. Yeah, so basically what we do here is we just call the test model with our model and our data and our tensor data. Let's save this and then let's go over to the browser. And we can see here. And then I should also say, this is just an example here. So in a real world example, you don't need to do this plot of the loss function and the mean squared error. It's only if you, but it's important that you will be able to monitor your machine learning algorithm. So if you find out that these are somehow not in sync, then you need to do something here. But here we can see here, so in the blue, we can see the original data, and then in the orange, we can see the model predictions. And then we can see, okay, it's actually, if you look at our blue dots, we can see that that is sort of some sort of a curve function. Whereas when we look at our predictions, we can see that it tries to predict with a straight line. And that's not so good. So maybe there is something that we can do about it. So maybe we can use a new model that will take this non-linearity that we have in our data into account. So let us define another model here instead. So let us go back to our code and let us check here where we have where we define our model, which is up here. And then we'll comment out this thing. And instead, what we're still using this TensorFlow sequential model, but what we do is we add some more layers. And these layers will help us in taking this non-linearity that we have into account. So at least in theory, this would help us a lot. So our result would look much better now with this new model. So let us save this and let's go back to the browser and let's run this again here. And then we can also see here in the model summary looks different because we have more layers here. So we have, this is the number of parameters. We have 128 parameters in the second layer and 4,160 in the third layer and 65 parameters. So this will help us take into account this non-linearity. And we can also see here that that both the loss function and the mean squared error will reach a low value, 0.01. You remember in our previous example, it was 0.05 or something, but it reaches this after something like 7 epochs. So that means that this algorithm is much more performant than the other. And we can also have a look here. We can see that that the orange prediction is much more similar to this blue, the original data. So we have managed to take this non-linearity into account. So that sort of concludes our first example here. So what I would like you to take with you from our example is that we could do some exploratory data analysis here in the browser using TensorFlow. We didn't need to write any code. We could use our TensorFlow visualization component, both to do the visualization, we could get the model summary, and we could also do some monitoring of our training. And as you could see, also the code that we've written is not so much, but we trained a machine learning model from scratch with new data in the browser using TensorFlow.js. So I think that is quite fascinating. And let me switch back here to the presentation. So now we've had that demo here. So yeah, so one way that you can use is if you want to use existing model into TensorFlow.js, if you don't want to produce your models from scratch, what you can do is you can convert the model. So what we'll see in our next example is we will have a model which is in the form of a Keras H5 model, an ImageNet model, and we'll convert that model to a TensorFlow.js layers format. And then we can use it in the browser. And the way that we do this is we use a command utility called TensorFlow.js converter. And then we just need to define the input format and also the output directory. And we can also use it, if we don't want to use it from the command line, we can also use it in Python. So in Python, what you can do is you import Keras, you import TensorFlow.js, and you import TensorFlow. And then you load your mobile net model, and then you use the TensorFlow.js converters, and then you use save Keras model as something. And then in your JavaScript application, you import TensorFlow.js, and then you can load the layers model and use it then in your code. So one question that we might ask ourselves here is, why would we like to use TensorFlow.js in the first place? So one of the reasons is that we don't need to learn another language. We don't need to learn Python or R or Jupyter Notebooks. We don't need to have any round trip from the client to the server. And you can also argue that the user data is more secure because everything will run on the device. So everything is local. You minimize the risk of having a man-in-the-middle attack, for example. And in addition, people will be able to use the browser application, which a lot of people are used to, which is highly interactive and easy to use. And you also have easy access to sensors like the web camera and the microphone and the gyroscope, for example. So there are basically three ways that you can use it. Either you can run existing models. So we're going to have a look at how we do that soon. Or you can actually retrain an existing model. So that means that you can specialize a model. Maybe you have a model which can recognize cars, but you want it to be able to recognize Tesla cars, for example. Then you can just retrain some layers in your model so that they will be able to recognize the Tesla. Or you can do what we did in our first example. You can develop your machine learning algorithm with JavaScript sort of from scratch. And on this slide, you can see a number of already made machine learning models that we can just use. So for example, you have models here for image classification, for object detection, for speech recognition, and so on. Now we're going to have a look at how can we use this in order to build our own image classifier. So let me switch over here to the browser over here. So let me show you what this image classifier will look like. So it will look, if we will select an image, so we'll select, for example, this image. And then after that, we'll select a model. So we will be using the mobile net model. And then after that, we'll push predict. And then we get the prediction here. So the mobile net model will tell us that with 0.99.9% probability, this is a strawberry. So we've done our own image predictor. So the question here is, how did we do this? So let me switch over here to Visual Studio Code. This. So this is basically just our front end here where we're loading the model. We can select our different types of machine learning model, if it should be MobileNet or VGG16. But the main important thing here is over here. So here we import again the TensorFlow minimized version. And then we are having a class here that is called ImageNet classes. I will describe what that is in a short while. And then we also have the predict.js. So that's where the meat of the application is actually performed. So over here we have, when we select an image selector, what we do is we read the image using a file reader. And then when we load a model, then we call the load model function. And in the load model function, we are actually looking here at our directory structure. So we look into a directory called TensorFlow.js models, and then we look for the name of the model. So in this case, we're using the MobileNet model. So then we can see here there's a directory called MobileNet. And then these things, the model JSON and these different shard, the binary files, I've gotten that through using this command line application, the TensorFlow converter utility that I was talking about. And then after that, when we click here on the predict, then we load the image and we load our model, and then we need to do some pre-processing of the image, because remember that we need to have our image in the TensorFlow.js format. So we need to do some pre-processing of our image. But after we've done that, we can just call model.predict with our tensors, and then we can extract the data, which is our predictions. And then we take out the top 5 predictions, and then we're using, so from the MobileNet model, what we will get is, we'll get the probability, and then we will also get a class name. But this class name is just an index. So we're using this index in order to be able to translate from the index into what a textual representation. So that's what we're using this ImageNet classes file for. So if we have a look here in the ImageNet classes file, we can see that this is just a mapping from an index to a text representation. So, and then we just return that. So that's basically it. That's what we needed to do in order to construct our own image classifier. So one of the important things here is that to recognize that we were using an off-the-shelf ImageNet machine learning model that anyone can download. And then what we did then was we converted this ImageNet model into a layers format model using this command line utility. And then when we've done that, then we get these files here. We get the model.json and we get these shard files. And then we can just use it in our TensorFlow, just in our web application, as we have seen here. So then let me switch over here to the presentation. So so now I've reached the final part here of my presentation, where I'm going to show you some examples from the real world. So one example here comes from Uber. So Uber, they have something they called a visual debugging tool called Manifold. So they're using TensorFlow.js in the browser for this. And you can also have a look at GitHub. So at GitHub, they have the code, and you can look through how it has been implemented. Another example comes from Airbnb. They are using something that is called identity document detection. And what is happening is when a user is trying to upload a photo, there's always a risk that maybe they have forgotten to leave, for example, their driver's license or their passport out on the table, for example. But then Airbnb, they run a machine learning model on the client, so in the browser, so that if you were to choose a picture that included sensitive information, you would get an alert before you uploaded that picture. And then we also have an example here from the world of music. So this is Magenta. So Magenta, they have a tool called Magenta Studio, and Magenta is using machine learning models for be able to compose music. And you can have a look at magenta.tensorflow.org to learn more. So I hope that you found this interesting. So I also have some references for you. So first of all, you can have a look at the TensorFlow official documentation, which is really good. And then there are also many courses here on Coursera with a focus on TensorFlow. And one of them is the sort of the introduction, which is called Introduction to TensorFlow. And if we want to learn more about this example with the image classifier, you can go to Deep Lizard on, they have a YouTube channel where you can learn more about that. And there are also plenty of different code labs that you can use. And then with that said, I would like to thank all of you. And if you want to reach me, you can either reach me on Twitter, where my name is Agravlis, or you can send me an email. But I see here that we have a couple of minutes here left. So then I would like to take the opportunity to say a couple of words here about AI42. So AI42 is an online AI school run by me and Eve Pardy, who is also an AI MVP. And the idea here with AI42 is we want to connect you with machine learning experts and recognized speakers from all around the globe. And what we do is we stream 2 times a month on Wednesday at 5 o'clock Central European time. And then what we have done is we've started with some mathematics and some statistics and some probability theory. And after that, we will go more into different languages like R and Scala and Python. And then we'll go more into tools like Power BI and Databricks. And we will build stone by stone. So eventually we will be able to set up our own machine learning pipeline, and we will look into deep learning and more advanced topics. So if you want to know more about this, you can follow us either on Instagram, we're on Twitter, and we're on Facebook. And if you want to have a look at our previous session, you can scan this QR code to get to our YouTube channel. Or if you want to know when we have our next session, you can scan the other QR code for our meetup page. So with that, I would like to thank all of you. Thank you so much.
Thank you, Håkan. That was a very nice introduction. Very interesting. We have some questions, so I would say let's try to answer them. So maybe we can get them on the screen already there. Perfect. So first question, how do you choose the right batch size for each use case?
Yeah, so that was what I said here, is that that's actually a science more or less in itself. So there is no common agreement on how you should do it. So a lot of, maybe one thing that maybe was not so clear in my presentation here is that machine learning is a very experimental field. So you learn by doing different types of experiments. So you both learn by using different types of machine learning algorithms. Like for example, you could see here what we did in my first example was that we chose one machine learning algorithm, but we could see here that it tried to use a linear approximation in order to make the predictions. But we saw here that, we need something that take this curve linearity into account. So then we had to change our machine learning algorithm. And it's the same thing. There are many different types of parameters that you need to be able to tune. And it has actually its own name, so we call that parameter tuning. And part of that is setting the batch size. So many of these things is something that you actually need just to try out, to do many types of trials.
Is there maybe wrong ways? Like, is there like stuff that there is a common agreement on how to not do it?
Well, I guess in that case, a common agreement would probably be to just run one sort of trial and you're not trying out different types of methods, because you will the more things that you try, the more you will learn about the problem. So there isn't really. So I think that's maybe a little bit of difference between, if I can call it, the regular programming, because with regular programming you can actually prove that this way of program is right, because you can write some tests and then you can get the test to be green. But the thing here with machine learning is more that you don't really know what the right answer looks like, and there are many types of different things that you need to take into account. Like for example, training time and what kind of computer power do you have access to, and where will it run? Because it might be that maybe you're constructing a machine learning model which is too demanding if you want to run it on a small device, for example. So there are many different things that you need to be able to take into account. So that's also why it's important to say that machine learning is actually an experimental field.
Okay, there is actually a similar question, because you mentioned performance, and Jean is asking, how is the performance in the browser? If you use a huge data set, it must freeze the browser at some time.
Yeah, that's true. Yeah, that's true. So you need to, running things in the browser is not optimal every time. So you need to make, some kind of judgment here. So how big data set do you have, and what kind of problem are you trying to solve? But I still think it's very usable, because the way that we can run it in the browser, it will open up machine learning to a whole new set of developers. So instead of just focusing on the machine learning engineers and the data scientists, instead now we can use machine learning for all web developers. So basically, if you know JavaScript and HTML, then machine learning is actually for you, so you can try it out.
Yeah, I think that's a really cool thing about this.
And maybe one other thing, if I can add, is also that another thing that this can be used is, usually, maybe in larger organizations, maybe you have one department, like a data science department or a machine learning department, and it might be that sometimes these are sort of isolated from the people who are developing the front end of the website, for example. But now this way it's much easier, because as you saw here, we could also do conversion from a machine learning model that you've written in TensorFlow. You could convert that over to this TensorFlow.js format, so that the front end developers could try that. So that then I think that's a way that you can optimize this sort of workflow between the data science department and the regular web development department.
Mm-hmm. Okay. Another question, a technical one. Would it make a difference if you shuffle the data multiple times?
Yes, I mean, so we did. Yeah, so I guess it's enough if you shuffle one time. I mean, it will be a different shuffling every time if you have like a true random generator. So I don't know if it would actually make any big difference if you shuffle it multiple times here.
Okay.
But I guess
the sense of the shuffling was only just, as I remember, like if you have an ordered list, or if the data is ordered in a specific way, so that with shuffling it, then you basically have some more kind of randomization.
Yes. Yep. Yeah. So the main idea here with the shuffling is that that you want this. You don't want to run into the risk that maybe, I don't know, maybe you have some data which is highly dependent on the previous values. Mm-hmm. And maybe that's not, representative for the whole data set. So that's why you want to, be able to shuffle. So you get data from the beginning of the data set, from the middle, and from the end, and you get this shuffling of the data. So that's a way that you can get the machine learning model to actually learn from the data and not just learn from the order of the data.
Okay. David is asking, do you use TensorFlow.js together with Python in some cases?
TensorFlow.js together with Python? No, I haven't. I haven't done that. But it's possible to build, a backend in a regular, backend in Python, and then you could use the JavaScript library in your front end, for example.
Mm-hmm. Okay, and last question. How many training images did you use in your example?
How many training images? Oh, for that.
For the strawberry, I think.
Yes. Yeah, so the thing here is that I didn't use any training images because the thing here is that what we're using sort of an off-the-shelf model that is already trained. So that was sort of a little bit what I was trying to explain here, is that that you don't need to start from scratch. So for example, if you want to develop an image classifier, you can just take one of these models that are already existing. So then you don't need to do any training at all. You just need to download the machine learning, the ImageNet model, and then after that, if you want to use it in TensorFlow.js, you just run command utility to convert this to a format that TensorFlow.js can understand. And then you can just use it. So I didn't do any training at all for my image classifier.
Okay, that was already the last question. Håkan, thank you very much for this very cool presentation. I hope a lot of developers, even the ones who are not into machine learning, can make use of it. Definitely very insightful stuff. Hope to see you soon again at some other events.
Yeah, thank you so much.
And
thank you.
Take care of yourself and see you next time.
For
the others, we are going into a short break, 10 minutes, and then we are going into our last session, and it's about serverless deployment of large NLP models. So tune in for the last session of today and see you in a couple of minutes again. Bye bye.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential. UiPath. Reboot work.
Welcome back to our last session of today. I am here with Marek. Marek is working at Slido. He's head of data there. How are you?
Pretty good, thank you. Thanks for having me.
So you are joining us from Bratislava, right? How's the weather there?
That's correct. Well, probably similar to Vienna. Pretty good. Well, let's say pretty good.
Okay, it's not that far away from us. Marek, in a couple of words, what would you say like people will take from your presentation today?
Well, I hope I'll try to persuade at least some people in the audience that these serverless things we've been hearing about are actually useful in some cases, and in particular, which is not that obvious, they are sometimes useful even for deployment of machine learning models, which wasn't that obvious for us, at least. Like, we might tell you a bit of history of Slido in the process as well.
Okay, looking forward to that. Marek, the stage is yours. You can share your screen, and we are starting right now.
All right, so thank you very much for the introduction again. My name is Marek, and my talk today, or the next 30 to 35 minutes, I would like to talk about how we at Slido managed to do some serverless deployment of pretty large NLP models, and we might tell you a bit of the Slido story and history in the process. What I'm gonna talk about is not my work in the slightest. It was very much a team effort. So you can see the real heroes on the bottom there. I am mostly a messenger here. Okay, cool. So I guess at this point, by this point, you are probably fairly familiar with Slido. It's that the little thing you see on the right next to the stream. At least I hope so. And Slido is an audience interaction platform, right? That essentially means that Slido can be used to help you interact with audiences by helping you to interact with audiences. We mean that it allows you to gather questions in advance or live at your event, allows you to create polls of various types and gather the information from your audience that way. And so there is a ton of audience interaction, at least in the current version of the platform. There's quite a lot of text. That's how you've been sending questions, and pretty good ones, if I may say so, throughout the day today. And where there's a ton of text, at least that's how we see it in the data team at Slido, there is a lot of potential to do interesting stuff, right? Interesting stuff in various ways, as we saw even in today's presentations. And then, well, that today basically implies in a fairly straightforward manner doing some machine learning. Now, the thing about doing machine learning is that the ways in which you can utilize it are multiple and not so obvious. So let me give you a bit of a rundown very quickly of where we found machine learning to be useful inside a Slido platform. So the first thing I would like to talk about is called key phrase extraction. The concept is very simple. Suppose you have a large event, a large gathering of people, large conference. For instance, Money 2020, it's a large fintech conference, or used to be a large fintech conference in the US. And what you can see here is a way in which we are trying to kind of give you a bit of a perspective of what was it about. So on the left side, what we see is a standard TF IDF kind of gathering of or like aggregation of the data, which shows you that it was probably about banks, as you would expect, about data, about maybe some things financial, about credit. But what we can do if we apply a bit of machine learning and some other techniques, especially pre-processing techniques, you can get a bit of a different picture. So data is still there, bank is still there, fintech just became an important thing as well. But there are other things that give you a bit of a slightly greater detail so as to what was the conference about. So like there is a higher risk in here, for instance, or regular marketing even, or credit decisions, or things like that. So that would be one thing, key phrase extraction, for instance. Then another one, and one we'll talk about today in a bit more detail, would be called sentiment analysis. It's a fairly straightforward approach, and like a fairly straightforward use case, but still a very powerful one, in which we allow you to take a look at the questions you got at your event, especially after the event finishes, and see what sort of sentiment might they kind of entice, right? So like you can probably get a bit of a picture of what was the meeting about just from looking at how many of these pictures, how many of the questions were positive, negative, neutral, and we obviously allow you to change the sentiment if we mess up, which we well, our models sometimes obviously do. Further, we have a thing called similar question detection, and the principle there is that if you have a fairly large conference, think hundreds of people sending tens of questions, that basically amounts to thousands of questions. How do you make it so that your question actually makes sense? In a sense, how do you make it so that what you want to ask, essentially what you want to learn from the speaker there, how do you make it so that this actually gets answered? Well, if you have a ton of questions, there's pretty much no way you can fit this in like 15 minutes of a Q&A or something like that. And so we've built a bit of a model and a UI around through which you can find that there are similar questions to the one you are typing, even as you are already typing it. So what we are looking at is an example of from the Boring Companies meeting in which there was the question of tunnel cost was basically associated with a bunch of other questions about tunneling. We also have a kind of varied approaches of visualizing the data, or like making more sense of the data that goes through our platform. In the Slido recap, we are trying to get a kind of a single way of, or like give our customers a single way of seeing both the recording of a meeting, something like the recording that will come from this meeting, along with the questions that have been asked in that particular meeting. And so what we are allowing them in here is to directly jump to the part of the video where these questions were actually asked. And the big thing in there is that this allows you to basically only go to that part of the video that actually makes sense, or like that you are actually interested in. Not that the whole content part of wouldn't be that interesting, but what we found is that people generally go after the questions because that's what they are mostly interested in. The presentation they can probably drive through on their own with the slides and whatnot. Okay, and then the one last bit of a crazy example, something we've released very fittingly on the 1st of April, is the following. When you ask a question, when you create a quiz in Slido, and suppose the question is who was the original creator of Mini, you probably know the answer, right? Like that's why you are creating that quiz question. But do you know the wrong answers? Right, and like in that sense, this little magic wand on the right is trying to help you come up with basically wrong answers, random answers that might not be correct, but might help you fill in or like create a bit of a quiz much faster than you would have if you had to say look up some inappropriate answers or something like that. What's nice in here, or like in this approach, is that you don't have to, our model doesn't have to be perfect. In fact, when it's not correct, it's probably for the best. Although answering Vienna to who was the original creator of Mini probably wouldn't be all that good. Okay, so there are quite a few places where we can see machine learning being useful in Slido. And if we go through the kind of summary slide again, doing that machine learning essentially implies, at least today, and at least in this current day and age, basically implies having Python stack. By that we mean these models are generally trained and evaluated and then deployed in something that can run Python. Well, that sadly wasn't the case with Slido's infrastructure for quite some time, and still not, because Slido is based on TypeScript stack. And so the question is, does this basically mean that machine learning or like these models are something that we cannot actually deploy? Well, it did look like that at first, that's for sure. But then we thought a little about it and came to the conclusion that, well, there is this thing called serverless, right? That there is this thing that allows us to run basically anything in any language without having to deal with that maintenance overhead. And so that is also the answer. Like, why did we even consider something like the serverless approach or the serverless environment? And if we had to like go through some real answers, it will be something like this. First of all, ease of deployment. Although it's not that straightforward, deploying or basically maintaining serverless deployments is way cheaper than having our good DevOps friends deploy as a server somewhere, then harden it, then maintain it, then make sure that it is connected to the right stuff, then make sure that it's updated, and so on and so forth. So that's the first thing. It's much simpler for us to deploy in this particular kind of way. There's minimal maintenance, which was one of the big reasons why we actually went for it. Minimal maintenance, not in the case that you don't have to take care of it, more of you don't have to do the standard administration tasks associated with them. There are some others, and like it has its limitations, but the standard maintenance is minimal, and that basically leads us to smaller operational costs, which effectively means that thankfully we don't have to bother our DevOps friends that much if we want to do something in this particular environment. Well, that said, it's not all rosy. It is possible, but it has its own fair share of trouble. So here's just a couple of things that we ran into, and like that kind of show that this is there is a limit, or like there are limitations to what the serverless environment can do. The first limitation is something you will run into pretty much right away, which is that there are these things called cold starts. And what we mean by cold start is that there is no server running somewhere 24/7. That's kind of what the name implies, right? It's serverless. So you kind of pay the penalty of cold start, of a function or a piece of code that hasn't been kind of started before. And that can take seconds even in some cases, and that really is problematic, and you have to find clever ways of working around it. Not to mention that the pricing is not that obvious, or might not be that obvious. What you are paying for is actually a millisecond, kind of the millisecond of execution, which is a different thing from renting a server for a month, which is like gives you a bit of a more of a like, well, a bit better what the expected costs are. What's particularly relevant for machine learning deployments is the fact that there are no, or the very there is no acceleration in terms of having some GPU or TPUs, and that's pretty significant impact. That has a pretty significant impact on especially machine learning models. And there are other a few more limitations, which you can see on the table on the right. That the most fundamental one is the function size, which basically makes it so that only roughly hundreds of megabytes of data can be deployed in this way. And we'll see how this kind of limitation is the principal reason why we even went through the trouble of doing what this talk will be about. So we kind of played a bit around with this, and the result is something we wrote up in this kind of a paper, which has a massively academic name, but in principle, it gives you the written narrative and written version of what I'm gonna talk to you about in the next couple of minutes. If you want to look it up, just look up a BERT and serverless environment and maybe deployment, and you should find all the details in there. All right, so what I'm gonna do in the next couple of minutes will be something very straightforward. We'll take two specific tasks or two specific machine learning models, and we'll see how deploying them in a serverless environment might look like, or what would it take to even deploy them in a serverless environment. So the first task will be very straightforward, mostly because it's a kind of a normal standard natural language processing task. It's a classification essentially into 3 classes in our case, and so we'll do sentiment analysis. Now, what we'll use for sentiment analysis is this thing called BERT, which you most probably heard about. But just to give a bit of a refresher, what does this bird thing do? I'd say is a fairly simple thing, really. So as an input, you give it your text, a text of, say, a Slido question, which you can see on the bottom here, and that Slido that question, in our case, the Slido question, will be kind of tokenized in an interesting manner. That's a separate talk, but in principle, we give it that text. It will create its own representation, and that's it. That's where its task ends. From there on, we take that representation, basically fine-tune a very small, or like train a very small, even something like a linear logistic regression, and get an output for our classification. In the case of this example here, it's a binary classification between negative and positive. So in other words, what that bird is capable of doing is something like this. You give it a sentence in text. It replies, or like its output is a vector that basically kind of summarizes what that sentence might be about, and you then take this vector and train the model of your choice to best fit this data set you got this way. Now, we've heard a lot about how BERT is basically eating the world of natural language processing, and it's very much the case. But what does BERT know about Slido questions, about a particular language of questions which can be at the most 300 characters inside, right? It's not even. It's probably even different from, say, the language that you can see in Twitter and so on. And so the answer is exactly what the slide looked like. Well, not much, not really nothing, but not much. And so to give it a bit of knowledge about Slido questions, we attempt a process called fine tuning, in which we take a BERT model. The standard BERT-based model, use about 70,000 questions that we have with their appropriate labels, and basically fine tune the BERT-based model. Now, with this kind of model, we can already do interesting things, but turns out there is a bit of a trouble ahead. Well, the model size on its own, just BERT-based, is about 400 megabytes in size, and the PyTorch library itself, which we need for inference, is another 400 megabytes. So essentially, just on the limitations level, this is a no-go. So what do we do about that? Well, if the model is large, we can probably go and see if we can train a smaller one, and that's exactly what we'll do, because otherwise we won't be able to fit within this limit of the lambda, which is 250 megabytes. And so what we'll use is a concept called knowledge distillation, in which we'll have two models. One will be the teacher, the other one will be a student. And so we'll use this large model of ours. We'll call it the teacher, and this teacher model will then take a whole bunch of unlabeled examples, which we have plenty of if we really want to, and use the predictions of the teacher to train the student. So the student will see both the 70,000 examples we saw in the previous example, and we'll also see a huge bunch of labeled data that the teacher will pre-label for it. And now in this way, we are kind of trying to get the student to mimic what the teacher would do on examples neither of these saw. Like on examples we don't really know the ground truth of, but this way we are trying to distill the knowledge of the teacher into the student. And so when we do something like this, we can finally answer yes, we can make the BERT model smaller. And the way we do it is by fine-tuning the BERT again, like by using the fine-tuned BERT-based model, labeling a whole bunch of examples with it. In this case, it was almost almost a million other questions. And using a smaller version of BERT called TinyBERT, we've been able to fine-tune the TinyBERT such that its final size was 56 megabytes, way smaller than 400. And as we can see in the next example, the accuracy or the performance of the model didn't really go down that much. I mean, it went down, and we had to kind of resort to a different kind of model, a slightly larger mobile BERT, which is 98 megabytes in size, to get to the performance of the BERT-based model. But still, the performance is relatively comparable, and the size reduction is really significant, and so the accuracy drop we've observed was relatively acceptable for us in this kind of scenario. So that would be one thing. That would be how we can go from a large model to a smaller one using this concept of knowledge distillation. Here we have it again in nice pictures. So let me go through the whole process one more time. We have a gold data set that's a bit smaller, but thanks to this particular data set, which is very much domain specific, we can fine tune the BERT-based model. From there, we can take a whole bunch of unlabeled data, use the BERT-based model, this fine-tuned model, to label it, to label this larger data set, which we call kind of silver set, meaning that the data is not really golden, but we kind of assume that what the teacher model, this larger model, learned is of some value, and then we use this larger silver data set to fine-tune the TinyBERT model, and the TinyBERT model is what we can then use directly in some serverless deployment environment, which we'll talk about next in a bit. Cool. In a very similar manner, we can run into a similar problem in this context of a second model, which I would like to talk about next, which is called the similar question. The similar question detection feature. And so in there, we basically are trying to figure out the answer to the following question. Suppose we have two questions, question A and question B. Can we somehow automatically find out if they are talking about the same thing? In other words, if we have question A and question B, can we find out if answering any of those would provide the same amount of information? What that would then allow us to do would be to essentially give the participants or even the organizers of the meeting a way of going through the list of questions and then limiting the number of questions they would need to ask, because we would know that answering one would probably ask multiple. And so this kind of problem is what's called semantic similarity, and BERT can be used for this kind of problem. The way we would use it is nicely outlined in here on the left side. So we would have the first sentence as tokens. We would put a bit of a separator there. We would put the second sentence as tokens in there, and it would again be a kind of a classification problem in which we would say, is this similar? Is sentence one similar to sentence two or not? The problem with this kind of approach is that it could be used, but it's not really efficient enough. Using this kind of approach has quadratic complexity, especially in terms of the number of operations we would need to do. And so for 100 questions, we are essentially looking at 5,000 model inferences, 5,000 computations we would have to do. And so with any further question, the number rises exponentially. And so something like this is not really efficient enough for our real time and real life use case. And so what the approach we would need to go after is what's called sentence BERT. What SentenceBird does is that it uses basically the very same kind of approach as we saw previously, only in a bit of a different way, in which sentence A and sentence B go through the BERT model separately. The information from the BERT model, which the BERT model outputs, is then pulled together, and the final result is a single vector that represents the particular sentence. In here we have sentences vectors u and v, and we can see that using cosine similarity we can then compare these sentences, and we get a kind of a similarity score in between these two sentences. Oh, and what that allows us to do, provided that we have some nice indexing infrastructure prepared, some nice index in which we can index these, in which we can put these vectors. This allows us to basically massively limit the number of computations we need to the point where we can talk about a kind of just linear complexity in terms of questions, which is already something we can work with even in a real or like real world environment, even real-time environment. All right, there is still a problem though. The pre-trained SBERT models are really too large for our use cases. Again, we can see that the pre-trained model will find not only do they not know much about Slido content or like the language uses Slido and for Slido type events, they are also much larger than the limits we saw already, which are about 215 megabytes or even 500 megabytes. And so what we need to do is to basically train our own models with the intent for them to be at least a bit smaller. And so how we could go about doing that is to again take these mobile BERT and tiny BERT kind of models, these smaller models, and see if we can train those from scratch. And not only can we try them from scratch, but we can actually use a very similar knowledge distillation approach that we used in the previous model, in which we would use the cross-encoded the BERT model, which we got both sentence A and sentence B in the same input. We can use this kind of model to create or like to go through a whole bunch of question pairs. In this case, 500,000 pairs, and by doing so, it can prepare kind of a silver data set, which is a data set of questions which we don't know much about, but we assume that the cross encoder, which essentially is doing a simpler, fighting with a simpler task in which you get the contents of both first and the second sentence, and then you only need to say to what extent are these similar or not. We can use the output from this kind of model as the silver data set, and we can then use the same knowledge distillation approach as we had outlined before. So in principle, what we have here is that we'll fine-tune the large BERT model, which we cannot really use because that would be all too expensive in real life production environment, but we can use that in training. We use this large model to create, again, kind of a silver data set. And using the silver data set, we then fine-tune these smaller models, which work in the sentence BERT kind of a way, which only have a single vector as their output. And so this is what it looks like in pretty pictures. Again, we first do the generic training of a sentence BERT on the standard data sets, and then we fine tune it a bit. And again, exactly as we saw in the previous picture, we then deploy this. We then get a smaller model which we can then deploy to some serverless environment. The nice thing about this is that if we do it in this augmented way, in this knowledge distillation way, we also get a bit of a performance boost in terms of a metric which we don't need to talk much about, But if we compare the bolded line here and the other lines above, we see kind of an improvement. And let me tell you that improvement is kind of shows when you compare those two models on real data in real environment. Okay, so we talked a bit about the deployment, and that's probably one of the most important things we should discuss in here. And so let's get back to what it looked like. So the deployment kind of environment we would like to use will be AWS Lambda, mostly because Slido stack uses AWS, and AWS Lambda in principle is a nice example of what serverless environment might look like. Although we've also done experiments in Google Cloud Platform. And so for the sake of having only single platform to talk about, let's take AWS Lambda, which has 25 to 250 megabyte limit for the size of the package. Now we've managed to go down with model sizes to roughly 60 megabytes, which is great. But then again, there is PyTorch, which we need for inference. That's like 400 megabytes, and then there are other packages, like utility packages and whatnot, which we need for that to kind of clean up the environment, or basically take care of the inputs and so on. So what do we do about it? Well, thankfully, it turns out there is a way of essentially not using PyTorch if we do not need to or want to, mostly because PyTorch is literally a full-fledged deep learning framework, which is kind of a different thing from what we need right now, right? Like what we need essentially is just to do very quick inference, and that's about it. And so the model inference engine we've used is called the ONNX runtime library. ONNX, I believe, stands for Open Neural Network Exchange, which is an initiative spearheaded by Microsoft. The models are essentially protofiles, so they are very fast to load and work with, and also a tiny bit smaller. But what's most important about it is that the whole ONNX library is about 14 megabytes, which is very nice for our use case, because that's exactly what we need. We need the kind of utilities and all the other things to feel that or like to fit within that limit. And the 14 megabytes is something we should be able to afford quite nicely. So when we then deploy these, and this is a graph of using Tinybird for sentiment analysis and also MobileBird for sentiment analysis and in AWS Lambda, you can see an interesting thing happening in here. So one of the few parameters you can actually set for your Lambda function, or like serverless function generally, is the amount of allocated RAM. That's particularly the case in case of AWS as well as Google Cloud Platform. And the more RAM you allocate, turns out the more virtual CPUs will your code get essentially access to. And that's also what we can see in this graph, which shows that the more RAM we allocate, the lower the median or 95th to 99th percentile of execution time gets. And the nice thing in here, which is what I mostly want to say, is that around the 1 gigabyte line, we get under 100 milliseconds, even for the larger MobileBird model, which basically tells us that 100 milliseconds is kind of a line which we are willing to tolerate in production, at least at Slido, at least for the experiments we are running at Slido. And this kind of shows that we can get there even with fairly limited resources for the particular serverless deployments. Similarly, and we can see a fairly similar example in the S MobileBird, meaning the the model that takes care of the similar questions kind of problem. And in there, since the model is essentially a bit simpler, we can go even under 50 under 50 milliseconds in some RAM configurations. What I wanted to say in here, or I would like to kind of emphasize in here, is that there is a good reason, or like a good chance that for some deployments, this even makes the serverless environment a bit more cost-effective than like renting a small server on AWS. The smallest one you can find currently is about 12, maybe $15 per month for 1 GB of RAM. If you do million executions on AWS Lambda with a Lambda that has 1 GB of RAM, you are looking at about $8 of in costs. So if I had to sum it up, it would be something like the following. In our experience, it does seem like doing serverless deployment is kind of possible with these kind of, even though larger, let's call them versatile models. Decreasing the model size is of the essence. That's the most important thing essentially that we need to do. And what worked very nicely for us was to use knowledge distillation, mostly because we have experience with training these larger models, and then we basically have unlimited or very large amount of unlabeled data we can then use for the creation of these silver kind of data sets that are then used by the student models. If we then come to the actual deployment, ONNX and its runtime library is a very nice option, in particular due to its size and also the ecosystem around it. And finally, it might turn out that doing deployment in this kind of way in a serverless fashion might help you save the day in particular, if you kind of figure out how to play around these limitations. What I mean by that is that if you have to fight very hard to get some different kind of infrastructure set up for your small machine learning project, that's basically how you make it so that it's never happening, mostly because there are almost always other priorities. On the other hand, being able to deploy a smallish serverless kind of function somewhere might be at least that's what we find in our in our experience. It might be a bit more easier to do. Furthermore, as we talked about a couple slides back, it might even be, especially for deployments in which the kind of number of requests or basically the load you get is spread very unevenly. It might be that serverless really is the better option, in particular because you don't have one stable server that runs 24/7. And with that, I would like to thank you again for spending this time with us. Again, I'm mostly the messenger here. The real heroes are the data team at Slido, which you can see on the line on the bottom. And I'm happy to take any and all questions we might have received. Thanks again.
Thank you, Marek, for the presentation. Let's see if we have some questions. Oh, we have one question. Thank you. A quick one. How did you get the idea and how did you make the decision to try it? Could have been that you just waste your time.
Right. I'd say it's an appropriate question to ask, I guess. In our case, it was mostly that this was one of the few deployments vehicles that we saw as an option. What I mean by that is that it's not again being able to kind of find the infrastructure support for large deployments with, say, GPUs and whatnot is a much harder sell, at least that's what it was in our example, than doing something smallish like this. So to answer the question, how did we get the idea? It was one of the few options we really have. And how did we make the decision to try it? Well, it was basically this or not doing it at all. So
okay.
I guess we didn't.
What have been the other options?
Well, the standard options is that you generally have some piece of infrastructure set up somewhere else. In a sense, you would have a different kind of stack, right? So like Slido, most of Slido is written in TypeScript and the similar style technologies. And the other option would be to basically spin a stack that would be based on, say, kind of, Pythonic style technologies. Now, spinning it's probably not such a big deal, but maintaining for the long term, making sure it's hardened, and so on and so forth, that's basically makes it pretty difficult to, at least for something that starts as an experiment, makes it pretty difficult to for it to see the light of the day, as I would say. But I would also I should probably point out that this is not something we plan on doing for the long run. It's more like this is how we get started and validate that the models we are using or we are building actually have some potential to bring value to our customers.
Okay, thank you, Marek. A question, one comment from my side is we are using Slido as well for our Q&A sessions, such as this one. So it's really a cool product. The people like it, we like it. We use it for years actually, also at the in-person events. So thanks for the tool. What you announced, I think, in the presentation that there is this kind of prediction feature in the polls, right? Mm-hmm. Is it already rolled out or?
It is. It to a significant majority of our users, unless you have unless you cannot see beta features, you should be able to try it out. If you go right now to Slido.com to the administration interface and try to set up a quiz, try it out. Okay. See if it works for you, and if it doesn't, do feel free to reach out. Be very happy to hear about it.
We will try it out right after the session. Marek, so far all good. Thanks for the presentation. I hope to see you again also at some in-person event in the future. Enjoy the day, and that's it from our side.
Thank you very much. It was very nice to be here, and yes. I guess let's see each other next time.
Yes, and greetings to your data team.
We'll let them know. Bye-bye.
Okay, bye-bye. Okay, so this was already the last session for the Machine Learning Day, and it is actually our last live day before the World Congress. As I said in the introduction to the day, make sure to check out the WeAreDevelopers World Congress. It's an event that you don't want to miss. We have really great speakers, over 100 of them from all around the world. Some really cool industry leaders such as Sir Tim Berners-Lee, Mishko Hevery, Jeff Atwood, really cool people. Check it out, wearedevelopers.com/world-congress. Also, if you are looking for a developer job, check out wearedevelopers.com. There might be something in for you. There is a lot of jobs across Europe for different types and roles and languages and stacks and everything. Many of them already with upfront salary information. And last but not least, thanks again for making this day possible, to our partner of the day, UiPath. Thank you, my friends, and to everyone else, thank you for joining, and see you latest at the WeAreDevelopers World Congress in 1 month.
Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential UiPath. Reboot work.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.